Hey everyone, welcome to our first Let's Dev on Twitch. We've been teasing this for a while, so I'm excited that we're finally doing it. I'm Hassan, community manager at Unity. You may have seen me on a bunch of other streams where I've reviewed your Unity Play games or I've done developer interviews. Today, I have an amazing co-host. It's Kodrin, technical artist on our R&D team. Kodrin, tell us a bit about yourself.
So, hey everyone, this is actually my first live stream ever, so I'm happy to be here and happy to be part of Unity as well. So, I'm a software dev, but mostly a tech artist working on a team that's called Vertical, so anything outside the gaming. But I've been heavily interacting with VFX Graph, and today I'm really looking forward to share a bit of that knowledge with you guys. So, yeah, hopefully that's a good intro.
Yeah, I'm gonna be learning along with the audience. Like VFX Graph is something I'm extremely interested in personally. I've been using the built-in particle system. I haven't had the chance to explore VFX Graph as much, but I've learned a bit from Kodrin, and we're gonna learn a bit more today. So yeah, we'll be talking about the principles of visual effects. We'll be using the VFX Graph to explore those principles today. And to get started with the show, we're going to introduce concepts and the graph by creating a basic particle graph. We're then going to move on and explore concepts such as sine waves, noise and randomness, and using texture as data. And we'll do that by building and dissecting some exciting effects like potions. We're going to light things on fire. We're going to have autumn falling leaves effect. And then we're also going to be taking suggestions from you, the Twitch chat. So tell us what kind of effects you want to see, and we'll make them for you. And we're going to be, we're going to be asking you to ask for like what kind of variations to the potions you want, what kind of variations to the falling leaves effect you're going to want. So we'll be asking you that during the stream. So during the stream today, we're going to be using a lot of assets from the asset store as a backdrop for those visual effects, right? And currently, we have the asset store sale Discover 2021 going on, and that's currently live. And you can see here we have it's currently live. We have all of the newest and top assets in 2021 that are 50% off. Right, so there's all kinds of assets here. You have all kinds of shaders. You have different tools. We're going to be using a bunch of these in the stream today. You have Ethereal URP. Kodrin, can you tell them about this volumetric lighting tool? Why that might be useful for them?
So yeah, if you've probably worked in URP, you've noticed that the fog tools, the built-in fog that we have is currently, not as developed as the HDRP pipeline. So there's a lot of cool packages on the asset store that kind of solve that problem. If you're looking for like volumetric lighting needs in your projects, and yeah, like we just came across like some of these assets, like Ethereal URP really looks promising in what it delivers, especially like as Hassan is scrubbing through it, is like pretty impressed. Really up to the quality also almost like HDRP. But yeah, feel free to check it out.
Look at this beautiful stuff.
Yeah.
Yeah. Oh my god.
Volumetric lighting is always nice, man.
Yeah, it just takes your project to the next level. Honestly, it's unreal. So yeah, feel free to scroll through this page. You've got a bunch of like assets that you can throw into your project, kit bash things together, make them your own. We're doing that today. What are we using today, Kodrin? I believe we're going to be using this quirky series at some point. These little animals.
We got like a bunch of packages lined up, so really happy to be using a lot of the community created content. We got like apocalyptic worlds. We got hyper casual action props pack.
I believe we have the Dreamscape Nature Meadows that's going to be in there as well.
That's a popular one. Yeah, it's been used quite a lot as well. And we got I think you mentioned quirky series already, but Mahfouz potions as well. And yeah, that's like at the heart of one of the core examples we're going to be featuring.
Yeah, amazing. Okay, great. So yeah, check that out. Check out the sale that's going on the asset store right now. Kodrin, how about you intro the VFX series for us? So this is going to be the first of a few episodes, right? So let us know about that.
Yeah, totally. So yeah, I'll start. So basically, this came about when I was teaching VFX to my internal team, the Verticals team inside, and basically reached out to Twitch. Hey, let's do a VFX Graph series where I pretty much talk about like the principles of VFX. And really, the idea behind this series is going to be a series divided into three parts. think of it as episodes, like 1, 2, 3. This is being the first one. And the idea here is to basically approach it from a principles first mindset. So I think personally that when Unity released its VFX Graph as as a feature, part of the Unity engine, they kind of released also a lot of overcomplicated samples. It was kind of hard to really dive into VFX Graph as a beginner or as a person who's been accustomed to using something like particle system, Shuriken. So really the idea here is to empower you, the users, by really teaching the principles first, as opposed to just teaching VFX Graph. So this is really learn principles through VFX Graph, not VFX Graph and principles. That's the gist of it. And my approach to this is having 3 levels of difficulty. So this episode is more to cater towards beginners or people looking to transition. We're casting as wide of a net as possible. Sorry in advance if we can't go into like really specific details at some points. We try to cover as many bases as possible in the lot of time we had here. So
Kodran, I know when it comes to teaching and learning, you believe in the 80-20 rule of VFX. That's something you told me about, and I thought it was fascinating. I'd love for you to, I know you explained the process of learning tools to me as an annoying process, and you believe in making it more enjoyable and fun if we focus on the right things, right? So tell me more about the 80-20 rule of VFX.
Yeah. So 80-20 is not just applied to VFX, and it is applied for anything. What it stipulates is that in order to learn something, really to learn, it's an approach to learning, and it says that really when you're learning a new software or anything, 20% of what you learn really produces 80% of the output. Right now, if you're a creator, you're probably touching on Blender, Maya, you're probably touching on Substance Painter, touching on all these different software, and you have to move things from one pipeline to the other. And it can be an annoying process. So I understand that because I'm a creator myself. So what I really want to hammer home is that I'm going to be showing you like really simple tools within VFX Graph, not diving in into the nitty gritty back end of it too much, but really just to get you started and have some results straight away, and results that you can apply to actual context and gaming and to your own game, really, because that's what it's all about at the end. Yeah.
Great. Yeah. And since the name of the episodes is visual effects, the principles of visual effects with VFX Graph, we might take it for granted about what is VFX, right? So let's go for it. How about you explain what is visual effects? What are VFX to the audience?
So it might sound very straightforward and literal, but really it's anything that adds life to it. It's anything that you see that is dynamic on the screen that sort of has maybe at sometimes just a slight polish, or it could be at the forefront, the game itself, right? It can be as expressive as you want it to be. And really you can think of it as embers on a fire system. You can think of it like dust particles. You can think about weather systems. You can think about silhouettes of particles emitting from each other. Anything that's fire, bombs, explosion. All of these are visual effects, and there's an entire aspect dedicated to it. And if you look at games like League of Legends, for instance, right? All of that, the abilities, that's all VFX driven. So it's a field in and of itself.
It's interesting because in a game like League of Legends, the VFX can be really front and center, all the spells and abilities. But
exactly.
Let's say in a game like The Last of Us or God of War, the VFX are there to kind of build an atmosphere and an environment and to kind of pull you in and make it immersive, make the game more immersive. So they can be subtle or they can be very not so subtle, right?
Yeah.
And I think we're going to be doing a little bit of both today. We're going to do some subtle effects and some not so subtle effects. Like as we said before, we're going to light things on fire. So I think we should jump in talking about the purpose of the first episode, the VFX fundamentals. And we should pull up your GitHub repository while talking about this, so we can explain visually what we're going to be teaching today.
Basically, this is a work in progress, right? Right now we have it hosted on GitHub repository. Our plan for the future is to host it for free on the asset store, tied in with Unity. But basically, this is a lot of the samples minus the third-party assets that you can take. Really, it's under, I think, an MIT license. Use it for whatever you need to. And these are some of the samples we'll be looking at. Like Hassan mentioned, fundamentals, right? And really, when you're dealing with VFX, there's some core things that we can start touching upon. One of these things is like sine waves, right? how to like modulate and pace ourselves, how to create like custom curves, shaping functions to create interesting movements. Another one is if you've ever dived into VFX, noise is a huge component of it. It drives pretty much everything, right? So noise, randomness, forces, we're going to touch on that. Another thing is, you know, sometimes proceduralism is good, but we want to add more, you know, art direction to it. And this is where using data, it comes in handy. And one of the quickest ways to use data in VFX Graph that I'd like to show you today is actually baking them into textures or point caches and really creating some of these nice burning effects that you're going to see later on. As well as these are more advanced effects, but these are some things that we're going to touch upon in later episodes, but don't occupy your mind with it. And whatever we're going to show here today, it's going to be updated after the stream, so you know, feel free to revisit it because this is, like I said, a work in progress.
Amazing. Yeah, so we're gonna be we may have already posted the link to this repository in the chat. In the future, as Kodran said, this is going to be up on the asset store as a VFX Essentials pack. And as we go through the future episodes, we're going to be coming back to this package and updating it with all the VFX that we make. So it's going to be quite the thing to sink your teeth into in the future. So look forward to that. Next, we're going to talk about, so we've already talked about what visual effects are and how they might be used in games. So let's look at some actual examples of VFX in games. So I'm going to pull up my screen and we're going to look at our first game. Kodran, I believe you wanted us to look at Ghosts of Tsushima.
Yeah, absolutely. So really,
why Ghosts of Tsushima?
Oh, first of all, we're in Game of the Year. I don't know if it won Game of the Year, but it was pretty close to winning Game of the Year.
Right.
Maybe it was The Last of Us 2, but really, when it came out, I think you know, it was really popular because, you know, there's so many stunning visuals that come with it, and not just that, the lighting, the leaves, the atmosphere, the environments, all this is just super dynamic, and it's one of those games that really pushes VFX to really its limits.
Yeah, so we just want to pull up my screen to show the Ghost of Tsushima. There we go.
Yeah. So yeah, as you can see on like the screen, you know, there's this duel happening, but also in the background you have like these falling leaves, these rustling leaves, these trees, and all this stuff. All of this is VFX driven, and this is actually a good example that I wanted to take, from because we're actually going to be building sort of our quote unquote weather system or leaf system today, or at least dissecting it. And you can actually, after the stream, just pick it up and like use it straight away for your own purposes. And you're gonna notice that although it's as elaborate as, although it looks elaborate, really the principles behind it is actually just is very simple. And we're gonna revisit that with noise, randomness, and forces.
Yeah, so as you can see in this video, you know, you have the falling leaves, you have leaves on the floor, and then you have leaves that are rustling, moving at the character's feet. It looks like there's more than one thing going on. Are we building something as, let's say, complex as this today, or are we going to distill it down, Kodran?
Definitely not as complex as that. So we're definitely going to distill it down because, I mean, there's so many different systems working here with the character, with the wind system as well. Really, we're just going to take a slice of it. And I think that usually helps really understand one aspect of the system and make it more approachable for beginners or people coming from the shuriken particle system.
Great. And I believe the next reference you wanted us to look at was from Death Stranding. So we're going to pull that up now. What made you want to look at Death Stranding today?
Yeah, first of all, I really love that game just because it's so out of there. It's so different in a way. But the reason why I wanted to take a look at it is, first of all, this VFX, although it can be in the background, it can also be embedded in the mechanic itself. So if you look at Sam, the protagonist, one of his tools, right, is the Oberdeck, the terrain scanner. And what's nice about that is that everything in that is VFX driven. It's using what's called point caches, or maybe big textures to sort of get these points where you should walk, where you shouldn't walk, where you're going to step on, areas of danger, or if you're getting like pinged by some scavengers. This is actually something also we're going to be looking at today, how to bake some of these point caches to create a burning effect in a way. But very great example.
Great. And then we were also going to be looking at Recompile today, one of our partners that we often work with. So let's talk about Recompile. So pulling this up, and I believe this recompile might relate a little bit to the potion effects we're gonna make later today, correct?
Yes, it will
Yeah.
relate in some way. And the reason why I brought up Recompile, aside from being a gorgeous game, I think San recommended it as well, is that really this game is the beautiful expression between game mechanics and VFX being tied in together. It's not just tied into your abilities, but also the character, how he moves, how he jumps, how he navigates the environment, and it represents a sort of a unified vision of a lot of the techniques that you're going to see over these series, not just what we're going to see with sine waves and pickables or just floating things, like we see in the Asana screens right now, but also sine distance fields or vector fields or sort of like these nice Bezier curves that allows for this like lightning effect.
This is an example of VFX being front and center, as we said before, right? Like this game is like a moving VFX like masterpiece. The next game we're gonna look at that I'm gonna pull up now is The Last Campfire, which is like the opposite example of this, where the VFX are a lot more subtle and kind of in the background, right? So yeah, what made you specifically select The Last Campfire as a good example for VFX? So we're gonna pull that up now.
So Last Campfire, sorry, slurring my words. Played it during winter time, and it was also sort of this good example, like you said, that VFX doesn't have to be at the forefront, and it can complement any game that you see out there. And if you look closely at the video that's being shown right now, you can see these like dust specks, these dust mites, some of these light particles shifting when you have like a key light on a door. And really, it could be about that. It can be subtle and adds so much life to your creation. And because it's a stylized game, on top of that, you can really push that stylized look, even with the VFX that you're putting into it. And the weather system we're going to look at today, we can even slow it down and make it look like what you're seeing here. Very subtle, very nice and slow, not very dynamic. But this is just to say that any game can implement it, and any game has a use for it.
Okay, I can't really wait anymore, Kodran. I think we need to jump right into it and pull up your screen, and let's build our first. Let's introduce the visual effects and the visual effects graph by building our first little particle effect, right?
Absolutely. Let's dive into. All right. So imagining you guys can see my screen, right?
Now they can.
Awesome.
Yeah.
So this is the thumbnail that was used to promote this the stream, but actually, although it might look like very like there's a lot of things going on, it's just this tree. It's as bare bones and as simple as it can get, right? And really, I'm gonna try to like build it as we go, but for now, I just wanted you to pay attention a bit to the layout here, because this is how I work, and this is kind of speeds up iteration time. I have my inspector here. Inspector is really useful, as you're going to see, with VFX Graph opened up. The hierarchy window, just to select my game object and see my exposed property. And my project, just to navigate a bit more my graphs in case I need to like drag some additional stuff here and there. All right. And of course, my game window and my scene window right here, just so in case I need to navigate. But anyways, let's get down to it. So just going to brush over and give you a quick overview of how to think about it. You got 4 rectangles here, right? And these are essentially called contexts. And within these contexts, you get these blocks called operators. Operators can exist within context or can exist outside of it, like this attribute here, right? And essentially, a good way to think about it, you have your spawn context, which determines how many particles you want to spawn and how they should spawn. You have your initialize context, which is sort of like your start function. If you've ever played around with scripting in Unity, it gets called once before the update, when it, after it spawns. And this is really to set out your initial conditions for your particle, how they should spawn. Then you got your update, which is sort of like your void update loop. And it's how your particles behave at runtime, right? And here we basically have like just some mild turbulence put in here. And then you got your output, quote unquote, render context. So how are our particles gonna be displayed on our screen? And
Kojin, am I right in saying that the entire blocks from the context from spawn to output together is called a system?
Exactly, yeah. So good on you to notice that. We're usually in a graph right now, and now you're gonna see that as soon as all these things are connected together, you're gonna see like the keyword system here, and you are right, it is a system. And within every graph, you can have multiple systems working in tandem with each other. This is what makes it so versatile, so modular, and so clean to work in.
And we're going to see more of that later in the potion, as we're dissecting the potion, how we're going to have different systems working together, right?
Absolutely. In that case, it's going to be like 4 systems, but still grounded. So yeah, let me just quickly like disable this. So we're probably going to just create it manually, right? You're going to notice that you can press spacebar and just type in whatever context you have. Then you can just take one end of the node and connect it, and you're going to see it's going to automatically autofill for you. In this case, one an initialized particle. And then we also want to connect an update particle context, and you're going to see now our system is born. But our system is not going to render anything unless we actually connect it to something called an output, and you get different output contexts. If you're familiar with the shading, do you have an unlit and lit variation in VFX Graph? But just for the purposes of today, we're just going to use an unlit variation of quads. Particle quad. There we go. Yeah. At its basis, it's this. We're not seeing anything yet because we haven't put anything in it just yet.
So we're recreating what was just on screen earlier, right? That really cool, colorful particle effect. Yes, that right there.
Exactly. Yeah.
Let's make sure to zoom in a bit more because I think the chat is having trouble seeing some of the moderators. So let's try to, exactly. Increase the editor size and zoom in a bit for them.
Perfect. Yeah, thanks for mentioning that.
No worries. Yeah.
So let's worry about how our particles are spawned. So how many are going to spawn continuously? So for this, we're just going to put a constant spawn rate. And maybe we can just put it, 64 particles per second in a way. And our capacity here, you can see it as our pool, our memory allocation pool. So for this, at any time, we don't want our particles to surpass 4,096 particles. Let's just say it's an arbitrary number. Here we had, I think, like 100,000. Here we're just putting 4,000. Cool. So we have that. Now we just want to put a random velocity. So as soon as our particle spawn, we're just going to set its velocity random like we did there. There's different attributes. We're going to go into that a bit later. So if I click on a context here, you're going to notice in the inspector, you have all these different attributes. And essentially, this is how VFX works, similar to particle shurikens, is that you modify these attributes to modify the output and what you're going to see in the scene editor or the game view. So for now, let's just put the same thing we had here, add some randomness.
Right.
Let's make it -1, very uniform, -1 to 1. Gonna see it's we have these things here. They don't look like much. This is because we have a default texture that it always spawns with. Just gonna put no texture for now. Or actually, no. Maybe let's put our default particle spec here, right? And now they're moving, cool. But you're gonna see not really doing much. So we're obviously gonna need to orient them towards the camera. And for this, we're just gonna add an orient face camera plane. So now they're always facing. It's quads facing the camera.
Right.
We're also want to be looking.
So is this what you call a billboard effect, where no matter where you are, the quads face you,
exactly.
right? So you don't want to turn around the effect and then see it down the side. So it'll just be a line essentially. You want to see the actual texture.
Exactly. Right. And this is a good use case actually. Billboards. If I just spawn them one shot without a lifetime, you could do billboards, for instance, and it's actually a pretty cool use case, even for VFX Graph. So for now, let's change a bit the color, right? Let's add something more sprucey in a way. So we have a bigger idea of what's going on. Let's put something here, maybe turn on the alpha clip away. And now our particles, I don't think they're dying. So let's also fix that by setting a lifetime. Random. Which each particle is going to have a likelihood of having a lifetime between 1 and 6 seconds. And we also have the same problem here, is that we're going to need to resize them a bit, right? So we're going to have maybe a set size over life. And you can also always use attributes with what's called over life. And then you get access to this really nice, neat curve here, and you can really modify it. and suit your needs in whatever sense. And yeah, like you're gonna see it's
Already looking close. It's getting there. It's getting to what we had in the beginning. Very nice.
getting to what we had in the beginning, but we don't
Yeah.
have the nice, interesting movement we had at the beginning. No, nor do we have the density assigned to it. So actually,
What do you feel is missing? What can we add before we jump into the operators? Can we compare the two and see how, like, what we might need to get from this point to that point?
Yeah. So this is what we have here.
Yeah.
You're gonna notice that these particles are much more flat shaded. We can fix that by doing a bit of alpha clipping and adjusting the brightness.
Great.
And they're also moving in like a turbulent fashion. So we're gonna need to add some turbulence to it.
Amazing.
Right. And obviously they have a higher count to them. So you know what? Let's do.
So let's increase the count.
Let's do it. And I mentioned you could add operators outside of the context. So we're just gonna do that.
And let's make sure to read the operator names out loud, just in case for people who are unable to read the names of the operators. Let's just make sure to read them out loud for the Twitch chat.
Absolutely. So here we just add like a property, a uint, which you can convert to a property in this case, where you can say variable, spawn rate. That's a good name for it. And notice what I just did here. I converted one of these blocks into a property, and we can expose it, which means that when we click on particles, it's going to appear here as sort of an authoring property. So you can author this on your game object and not have to jump back into the graph itself. Really cool feature about it. And let's just up our capacity to 100,000.
Okay, so we just, there we go.
And
They seem a bit bigger, maybe. Yeah, so we just decrease the size.
let's decrease the size, and we can like also increase the alpha threshold. So we clip like the like nice grayscale values into like a more wider side of like the color space. And
So how does that clipping working exactly?
so you see we have a texture. Now this texture is an alpha texture, and it has like this white dot in the middle and all these grayscale values in between until it fades out.
Yeah.
What alpha clip is doing is that it crushes those faded out values back to the center.
Okay, so they're more solid little dots rather than these faint dots. Got it. Yeah.
Exactly. And so if you notice here, here's the result with it.
So in a way, you're making them smaller too.
Yeah.
And making each dot stand out. Great.
Yeah. And we also want to increase the brightness. So we do this by multiplying the color. You notice that we have with each property, you can either set, multiply, or add. If you click on the block itself, you can choose it here as well, or override. Override is set. So I'm gonna add the float property here just to determine our brightness. I'm gonna multiply by 3, so we want it 3 times as bright. You see, we're getting there. We're getting something here, and we can convert that also to property and call it brightness. So now we can author it within the game object itself. And now,
Super close now. It's already looking so good.
thanks, man.
Very
Always my
colorful.
best supporter. So.
I'm Kojun's #1 fan.
So we now we have that, and the only thing that's missing is obviously the turbulence. We want to move in an interesting way. So this is one of the most popular blocks in VFX Graph, and if there's any operated blocks that you're going to use over and over again, is the turbulence force. And this is just because it's so versatile.
Wow.
And with turbulence, we're going to crank up a bit the intensity, so it gets affected much more by that force. And we're going to talk about these forces much later on and visually represent them in 3D space. And frequency. So we want it to be more mellow, like more curvier for surfaces. You notice if I crank up the frequency, it's going to be like very granular, but we're just going to get some nice balance here, right? Similar to what we had.
Right.
And there we have it. You know, slightly different because of the colors, but
Yeah.
in
Pretty much the
essence,
same effect. You can look at the other one.
really.
Now, what if we turn them both on at the same time?
Oh wow, we're gonna have like duplicates, yeah. There you go.
There you go.
we can have them work in tandem, and this is the beautiful thing, as I mentioned. These are 2 separate systems, and you can just stack and stack and stack on top of each other.
Right.
Not like the previous particle system where you had to parent
And make one a child of the other, and then align them. Could you actually shift one off to the side so that we can more like show how they're actually 2 separate systems within the same graph?
Good, and that actually also brings up another aspect to it. So output render context gets only called once at the very end of the pipeline, not every frame. So this gives us a lot of leeway into adding offsets, for instance. So in this case, I just want to modify the position. So we're going to add a position.
Yeah.
And you notice we have 0, 0, 0. But if we just shift it a bit like this, or let's look in our game view a bit, and we can actually just shift it side by side.
There you go, and you have two effects side by side from the same graph.
From the same graph.
Kind of amazing. Yeah. We're gonna show you in the next effect how that's gonna save us a lot of time. People in the chat are noticing my own little visual effect in my room. To bring the smoke effects on stream today, you know. And I noticed some people even noticing the model of my 3D printer. Reality, that's right.
You got like a laboratory there. I wish I had also a 3D printer.
You can come use this one anytime, Codrin. It's yours. What's mine is yours. But yeah, okay, great. So let's jump into the next section where we talk about sine waves and modulation.
Absolutely.
Now that we've built our first little graph together, let's dissect the graphs you've already prepared for us.
Awesome. So we're gonna go quickly into some like theory and review a bit like sine waves. But let me just open my graph here called waveform, and this is all included, by the way, inside the GitHub repository. This is the setup we have here, and I'm going to talk right now about sine waves. Sine waves or cosine waves are sort of, or any kind of waves in general, are sort of your best friend when it comes to building a lot of these simple basic effects. And you can imagine if you've ever played like a game like Hades, right? You have these pickable object that floats up in the sky, like a sword or a potion, which we're going to build later on. And this requires sort of like a modulating force behind it, because we're not going to hand author on our timeline go up, go down, go up, go down. We want it to be at least somewhat procedural in a way, right? And I built some effect graphs to showcase some of these things that are available to you in the VFX graph. And really, all these things you're seeing right now are the same graph, just authored in different ways through these parameters you're seeing here. But they're all using this.
Make sure to zoom way in, Codrin, for the.
Way in.
Yeah, and keep it centered.
Thanks for reminding me all the time. He's always there. That's why Hassan is here.
That's the only reason I'm here. I'm the zoom guy.
Yeah. But yeah, so you got a sine wave operator block you can use outside of the update context. And this, we're just really pushing it into a switch node to just have these different things, because we can switch between them, and just setting the Y value here of these different cubes. If you notice, we just zoom in, these are actually just spawn cubes that just follow this sine wave. And sine waves are so useful for us because they go into shaders, what's called shaping functions. Sometimes you want to move things in a very particular way according to some animation curves. If you ever done animation before, your curves are your bread and butter for achieving really nice smooth animations or more interesting effects. And this is one of the tools that we actually have in VFX Graph. So what we're doing here is just we're taking VFX time, which is a built-in operator that fetches us the total time that we have going on in seconds, I think. Yeah, total time. We're also putting a property here to multiply it by the sampling speed so we can make it go faster or slower. And we're also taking our position and we're adding those together to input into our sine waves. So we put the input here. Sine waves have three components to them. The frequency, two components, the frequency and the amplitude. Frequency can be expressed with this parameter here. So high frequency is very packed. It's going to be like very jittery if you're going to imagine a potion floating. So it's going to be like
jumping up and down.
Exactly.
Pick me up, please pick me up.
Yeah. Whereas a very low frequency is very smooth, right? You get these nice smooth effects.
Right. Potion doesn't really care if you pick it up or not. You know, you can do it. I don't care.
It's gonna wait for you all its life.
All day.
Yeah. And then you have amplitude. So how high it goes, right? You have your min and max. In this case, it's from 0 and 1, but we can put it to like 2, and you're gonna notice based on the color as well, you know, how that behaves. And keep in mind that all this time, right, we're also using whatever is outputted to, you know, produce a color sample, because all these values are at the end of the day are going to be between 0 and 1, and we can gradient sample it. So already we have a use case here of how we can use it with colors, but later on we're going to show you how to use it with positions and maybe rotations if you have some use for it as well. not only sine waves, but you can actually author manual curves. So if a sine wave isn't cutting for you, or if proceduralism or sine waves or and randomness isn't cutting out for you, you can also have access to sample curves. And sample curves, like you see here, if you look at it in this example, you can really edit it and have different presets and really make your item move in interesting ways and more art directed ways, because that's what it's all about, right? Showing you some ways where you can empower the art director or the artist itself as
Yeah,
well.
and this is a literal one-to-one. You can literally control the wave, right? And you're seeing that on the screen on the right. You're moving these cubes,
Yeah.
right, together, and you're controlling them with that shape, and it's translating in the VFX on the right there. The visual effect
Exactly,
on the right.
exactly.
Yeah, amazing.
And these are just essentially the same graph, but using different selectors. So, talking about reusability, you have a switch statement here, and you basically can just slide this thing and get different channels, right? So if I select 1, it's going to take this curve. 2 is going to take this curve. 3 is going to take this curve. This is great ways to think about reusability in terms of your graph, because this is the power of VFX Graph, right? You don't want to always have to duplicate systems. And if you have a minute change, you don't want to have to cascade through all that mountain of parent-child relationships in your particle system. You want it to flow and just change one parameter.
So let's illustrate that by jumping into the moving on to the potions.
Great.
And jumping into the potion graph and actually building that together.
All right. So let's actually go a bit into here, right? Show you a bit with the final result, what we're aiming to achieve. And this is something that I believe we built with one of the asset store packs, Mafu's Potion. Am I correct, Hassan?
That's right. So this was using Mafu's Potion pack, which Kodran had a lot of fun with. He jumped in, and there's so many different high quality potion options here, and he like manipulated them to create all kinds of crazy effects, which you're gonna see. So check that out in the asset store. We're gonna drop a link in the chat to Mafu's Potion pack. Thank you for that. Go ahead.
Yeah. So the reason why you used a bit of third-party assets, sometimes it's nice to ground your visual effects and have some Lego things to build with, but we're essentially going to look at how these potions are made. And these potions are essentially made just with sine waves, reused over and over again for color, for position, and sort of these things you see here. And this is the actual graph you're going to be, I'm just going to try to supply you after the stream so you can play around with it. But you're going to see here we have 4 systems. 1, 2, 3, and 4, right? And each system you can name them. I named them here. I don't think I named all of them. Sorry in advance. I had to pull some things here last minute, but we essentially got the main object, which is the hero asset that's in this system. We got a glow around the main object, which you're gonna see maybe behind that. I don't think I have it that emphasized here, but here, you can see it more if I just amp it up a bit. There's a glow behind it. And you got the tertiary objects, like these small sprinkles of bottles going around it. And you also got the glow on the ground. So this is actually not a light inside the thing. VFX is nice. For all these VFX artists, you can fake stuff by having quads illuminate at the same pace as these bottles going up and down to create this illusion that it's lighting things on up. So yeah, let's actually go more rudimentary. This is what you're gonna find in the samples. I just put cubes here just to get these assets and not really worry about these assets when you're building it. It's good to have an environment where you can debug things more easily. And yeah, let me just switch graph. It's called the pickup graph, whereas the other one was called the potion graph. But yeah, let's dissect it a bit.
Yeah, so let's turn some of the systems off so we can show you what each system is doing, right?
Yeah, I'm just unchecking their spawn condition, by the way. And this allows me to just not worry about anything that's around it. So right off the bat, we got the main object, our hero object. And we got a lot of cool things going on in here.
Let's zoom in a bit more.
Oh yeah, let's just let's go into it. Yeah.
And when the effect gets a bit heavy on the right, we might want to hide the effect, because I believe the heavy particle effects are adding to the compression. But right now, it's a lot clearer. So when we start turning on all the layers, we might want to hide it a bit. Yeah, for chat's sake.
Yes, thanks for reminding me that.
No worries. Yeah.
Yeah. So in this case, we don't want particles to die. So we're not using a constant particle spawn rate. We're just using a single burst. One particle, which is going to be a potion. And we're not going to set any lifetime related attributes. So nothing over life or nothing set lifetime random. This stuff is just going to exist until there's some logic in the scripting that's going to pop it and make it disappear. Obviously, we want to center our particle. So we're going to put it at 0, 0, 0. And we're just going to disable a bit these things. So notice that without the update runtime things that you see here, let's also disable the color. This is what you get. And really at a high level, I'm just using the sine wave functions that you see, the odd sine wave operator block, to undulate up and down in a very smooth way at a very low frequency. You see here I have a levitation speed property attached to it to make it go faster or slower, depending on how I want it to look, right? You see here levitation speed. And really the output values are going to be -1 to 1, and I just scaled them down a bit. I just tied them into the Y position. So this is what it's going to happen. And obviously the X and Z, I don't want them to move, so I put them 0. Okay. Then in VFX Graph, you can also author rotation. Rotation is expressed through angles, not rotation.x or whatever you're used to seeing while you're scripting. Okay, so it can be a bit confusing, but this is what we have. And essentially, we are just adding random arbitrary decimal values to each of the X, Y, Z channels.
So this is happening at update at runtime. This is the update. Sorry, the update context, correct? Mm-hmm. Which is the second context.
Yeah.
And so an angle change is being added every frame, and so it's continuously rotating, right? Now we have a really good question from the chat. Is there any advantage to putting set size over life and add position on the output instead of the update? So in this example, you've added it to the update, but chat is curious what would happen if you added it to the output, and there's a big difference. Am I right in saying that?
Yes.
Yeah.
So set size over life, these are operators that I usually advise them to use in either initialize particle or output particle. The reason that being is behind the scenes, VFX Graph kind of handles them to like shift over lifetime, right? It sort of has these built-in functions called over life that sort of helps you automate that process. It will handle based on the curve how it's going to evolve over its lifetime until it dies. Now, there's also a clear advantage to adding them at the output particle cube versus the initialize stuff here, is that because the output particle cube, the output context gets executed at the very last moment, the feedbacks within editor are going to be instant. Whereas if you put it here, in order to reflect the changes, you're probably going to have to save and recompile the graph. So good practice, I always use them here if there's anything set of size of life. In some exceptions, I might get them to use initialized particles, but really either use it here or here. Really.
And can we illustrate adding a change in position to the update versus adding it to the output? I feel like it will clearly illustrate the difference there.
So let's put an add position in the output render context. So if you want to offset anything, either you can do it at the beginning in the initialize or at the very end. And offset is a good example if you just want it to be paced more to the left and stay that way while it's updated.
So after everything is rendered, it'll just be shifted off to the right because you're adding it to the final context, which is the output.
Yeah. Now, watch what happens when I put it into the update. So if I put in the update, because it updates every frame, oops, sorry, you're gonna notice that it flung out of existence, and it's a small dot.
Got shot into the sky like Team Rocket.
Yeah. And this is because it's updating every frame. It's gonna go off to oblivion.
It's constantly adding that position.
Exactly.
At runtime on update per frame. So it was a very good question. Thank you for that.
Thank you, whoever asked it.
Yeah.
So yeah, let's go back into the meat and bone of it. So yeah, we have this sine wave actually modulating our position right now, but we also wanted to modulate our brightness and our color, right? Because we want this to be in sync when it's going up and down. Luckily for us, we can use the same output from that sine wave to just essentially remap it, because our value here is -1 to 1. We map it to 0 to 1, and now we can sample anything that's gradient related from 0 to 1. And this is what's happening here. So now we got a gradient that's going up and down and just being sampled with this exposed property that you can edit here. Yeah. Same thing. We're going to go into multiply color because we just want to add a bit more brightness. So if you notice here, We're just essentially multiplying the color to like make it more flashy.
Okay, first of all, just sorry to interrupt. We just got rated by a party of 355 by Lana Lux. Thank you so much, Lana Lux. Thanks for joining us. Hey
Thanks,
everybody,
Lana Lux.
welcome.
Welcome to the stream. Thanks.
To the
Really
stream.
appreciate
We're talking about the principles of VFX Graph today. We just went over the basics and the concepts that we're teaching. Right now we are talking about we're dissecting a potion visual effect.
Yeah, absolutely.
Potion is just walking us through that graph right now, and we're talking about specifically sine waves and modulation. So welcome everyone.
Welcome everyone again, and yeah, we'll move a bit forward. So that's pretty much done with it. So now we have a modulating object here, a potion. You can imagine it as a cube. Only thing that's missing is now to do the glow, right? And the tertiary things. So let's look at the glow here, right? You see how it's behaving, and it's behaving in sync with the modulation on the y-axis. Right. Let's turn that hero potion off. So we see what we have here. And really, same thing. We're using a sine wave in this case, but instead of using the sine wave for the position, we're just using it to multiply the size. Again, you can use these to modulate any attribute you see in the inspector. These ones. Yeah.
Let's just zoom in a bit more again. Sorry for the chat.
Oh, yeah. Always remind me, Hassan.
No worries. I got you. I'm the zoom guy. Like I said, that's what I'm here for.
Yeah. And if I turn this off, you notice that it's not modulating, it's just modulating the color right now. But let's turn that off. And essentially, we are faking lighting right now by just using a quad. And Unity doesn't want to play ball, so it's not showing the wireframe, but it is there. It's just a quad here that is, if I put rotating around in the update context in case you have a custom texture, so it has more dynamic feel to them. But we're just going to stick to that default particle stuff that we had here because it's just more beautiful. And again, we're also multiplying color to adjust more brightness values. But if I turn this, if we're now rotating, and if we're just setting the position, you're going to notice that now it's like rotated 90 degrees in a way. It's not facing up when we had it. And you notice back to that question, when it comes to offsetting, these things are good to set in the initialize. So in this case, I want it to offset so it looks up. It points to the up direction.
Right.
And I also want it to be just under. So that's why I put the Y position to be just under the hero potion. So it sits just underneath it.
Yeah, before you add any fancy effects, you're just placing it, putting it where you want it to render, right? And then adding all the effects to it. Yeah.
Right. And then we can worry about polishing a bit. So we add a bit of rotation. We change a bit of size here because we don't want it to be overly small. We want to be like actually define a set size. And then we go into it. And then this is where the magic happens, right? Sine waves. Boom. And if I turn back the hero potion, now you see, very interesting because they're both using the same gradients. Right here. They look like they're affecting each other in a way, but this is just an illusion played around with quads and meshes.
So this is the advantage, right, of having two systems within the same graph where you can link things together. Can you show how the colors are connected again?
Exactly. So we're both using gradient colors with a sample gradient, and this gradient color is the same one that we're using here. So they're always going to use the same gradient.
They're just going to be in sync by default, how you set it up. Amazing.
Yeah. Now we can make things be even more in sync, like this one. This is essentially the same concept, like a quad here, but instead of making it point up, we just use this node to orient to face camera plane, and made it a slightly bigger by taking the size whatever we had here. Same sine wave that's affecting the main hero potion. See, we're reusing things. We're just multiplying a bit to get it slightly bigger, right? And then we're taking the same output that's making the hero potion move and placing it with the same set position node in this one. So we get the glow around the object moving with the object. If I don't have it, it's going to sit there awkwardly, right? So reusability is a huge thing in VFX Graph. And you can even push it further with subgraph blocks and subgraphs, something that I highly encourage you to look at as well. So now we have the glows handled for us. Cool. We want to add some sprinkles. Always the third element.
Missing something. Yeah.
The tertiary element.
Was missing.
And we're just going to turn this off so I can focus a bit more on this, right? And this is just slightly more elaborate. But what we have here is actual spawning particles that die out. So this is why we're using a constant spawn rate. We're also setting a lifetime random between 1 and 3 seconds. Same thing with the size for more variability, because we don't want it to look uniform like this. We actually want to have a bit modulation. Randomness is just super useful. And so many things that are attribute and random that you can set at initialize or output. So watch out for those. We can offset a bit, small decimal values just for fun. But essentially here we're using a set position node, and we're essentially just using a random inside sphere subgraph. I mentioned that this was a modular tool, and we're using a subgraph from if I right click and enter subgraph, we'll see that this is the stuff that's embedded within that operator block. This is all included, by the way, in the samples made. This one in particular was made by one of our Unity employees, Keijiro Takahashi. Shout out to Keijiro, he's very great. He's an amazing, prolific VFX artist. Great resource overall. And so that means that our particles are now spawning inside a sphere versus just like, in one single place. And from then on, we want to make them, rotate a bit, so that's why we had the add angle. So they're not just static rotation. We're going to do the same thing we did with that hero potion. We're also going to make them float slightly. So that's why we have these small undulation here. And it's the same sine wave principle tied with the time and some random numbers. So they're each floating in a different way. We don't, not in sync.
So you didn't use the same sign as the previously, just for creative purposes here, right? You just wanted the effect to be a little different.
Yeah, let me actually illustrate, because that's a very good question. Here, it's just the time input.
Yeah.
And the sine wave. Here, we're getting the total time from the VFX multiplied by some random number that is generated per particle. That means that each sine wave for each particle is going to be in different sync. So they're going to have different levitation.
Otherwise, it would have been. It would maybe look too uniform. These little effects that are floating around don't look as random. Maybe,
you're gonna get a bunch of these sparkle particles that are just gonna go like whoop together, and you don't want that. You want more variability and randomness. Sorry, friends.
Yeah, it's a nice combination of the two, right? So the potion is like more predictable. It's like going up and down and turning, and then the particles that are around it are more random, and it all kind of comes together.
Yeah. Exactly.
A potion that just really wants to just be picked up by you.
Absolutely. We got to make it very appealing. And you're going to notice that, oh, wait, your particles are also orbiting. You're absolutely right. They're not, before all the sine wave stuff, we had them a bit static, just floating in the air like this. But we also had some orbiting, and thankfully, VFX Graph also offers operator blocks for rotating in 3D space. In this case, we have Rotate 3D, which we use with an attribute. Any attribute you see here, you can use a node outside of it called get, and you're going to see get attributes, and you have this entire list. In this case, we're only getting position, putting it inside of it. Sorry. And then
so are the attributes the same across every context, across the initialize, the update, and the output?
Yes. So each of these, as it cascades down, has a memory of all these attributes. So they're equally accessible in each of these contexts.
Okay.
Right.
Good to know. Yeah.
And now you're going to notice that some of them are rotating clockwise, some of them are rotating counterclockwise. This is just because in the angle, we specified some randomness to it between a negative and a positive number. That assures that some of them are going to be using a negative angle speed counterclockwise, and some of them are using a positive angle speed, so clockwise. Right. And yeah, that's pretty much the gist of it, really.
Great, so let's see all the effects coming together, and then we should swap out some of the meshes to actually, right now it's just a cube, right? But like Kojin was saying before, it's really fun to use these placeholders. In this case, we're using Mafu's Potion Pack to actually make it what it is, a potion pickup. So let's show people how we can actually change that. I just want to shout out Lana Lux again. Thank you so much for the raid. Lana Lux is an incredible Unity developer and streamer. She's streaming almost every day for like 8 hours a day. She does everything from coding to 3D modeling. She basically does it all. Definitely check her stream out. Really, really incredible.
Thanks to Lana Lux again.
Yeah.
So let's go back into our potion scene. So we have here. So what essentially is left for us to do is replace those cubes with actual meshes. Luckily for us is that go into our potions graph here. Notice we have the output particle cube. Now we have an output particle mesh.
Yeah.
And essentially here we specified a property called potion mesh here. So we can input through our inspector different meshes and a potion texture. So we can input a different texture depending on what our needs are. And we did the same for this. For that, we did the same for the tertiary particle. So here we went and specified also a particle mesh, but this one is kind of hard-coded because we don't have a property to change that.
Right. So in this case, there's no public property, and so we're not changing the instance. If you change it, it's going to change in all of the all the models. Whereas if you make a public instance, you can make it unique and specific looking, which is what we're doing for the meshes in this case.
Yeah.
Right.
So,
and I just want to tell the chat right after we change the meshes, we're going to ask you what kind of potion you want us to make. So let us know what kind of potion you want us to make right after this. We're going to spend about 10 minutes changing this potion into a potion that you recommend. So let us know, do you want a poison potion, a lightning potion? What creative potion ideas can you come up with? And we're going to try to use what we have to make it feel like the potion you suggest. And the suggestion that we choose is going to win a Unity Lego minifigure, right? So we're giving out these minifigures, and speaking of Lego, next week on Monday, we're gonna be doing another stream with the Royal Danish Library, where we're gonna be playing games from the Lego Ideas contest. So we're gonna be playing some Lego games next week on Monday on stream, and we'll be giving out even more Lego minifigures then, right? So let us know and what potions you want us to make, and the one selected will get a Lego minifigure sent to them. All right, sorry, Kodrin.
Yep.
Continue.
Let's do it.
Yeah.
So we got a potion here. And now because we set these things up nicely for us so we can author them and edit them, this brings up the window for a huge amount of reusability. So let's just duplicate this one here. So now we got a different potion. Let's name this one extra so we know which one it is. And now we have like our gradient that we expose here, which is the glow, and we also have our meshes. So let's actually pick a potion from Mafu's pack. Let's do oh, the snake one looks nice. And you see we have a snake potion, kind of looks green, and kind of doesn't fit really with the mud potion like the orange hue. So let's actually change the gradient a bit. Let's go like much more green here.
Let's maybe turn off the other potions and zoom in closer to the graph so that the compression doesn't get too high, so that the chat can see what you're doing.
Sorry.
No worries.
It's actually, I think I almost deleted all of them. Good, yeah. Let's go in and get it in closer, yeah. So yeah, like this is the inspector window. And yeah, we can also change the glow. And you're gonna notice that it cascades to our tree and rearranges the glow you have around the object. Let's just get rid of the stuff here, put it black, because we don't want to have any like orange hues. Notice we also have like a parameter for scaling. Sometimes when you're working with meshes, they're not in center. The pivot point might be at the bottom. You have something in VFX graph called set pivot XYZ to sort of change that if you want to pivot to be more towards the center, like we have here. So if I change that, it's going to take the origin point of the geometry and change it so it's much more in center. And you're going to notice that with meshes, you might want to like scale them up a bit because sometimes they might appear tiny and you might not see them. Just scale them up like we have here. So I have a parameter here to adjust its size. And
you can make these adjustments on the fly. It's no problem.
Make the adjustments on the fly. And totally, yeah. And we have potions right now, so let's do something even more interesting. Let's let's take the output of these tertiary meshes and make it a property as well. And I just took a connector node, and it was very easy to find out which one you should be connecting with. And let's also take the texture output and make it a property too. So we have mesh here, convert to property, tertiary. Oops, sorry. Mesh Might have some spelling mistakes here. Yeah. Remember to expose it. And we're also going to convert this to a property. Tertiary texture. And we're going to expose that too. Cool. So now you're going to see we have these additional things that we can override and play around with it. So let's duplicate our stuff again. And let's try something from a different asset pack. I don't know. Grenade.
Well, actually, before we do that, let's actually look at the suggestions, and maybe we can jump right into the audience suggestions.
Oh yeah, good idea.
And then that way we can actually jump into the pack and do that. Okay, so let's look at some of the options. So Ruhan Bello suggests a fire potion with flame particles. I'm just gonna run through them, and you let me know what you think, and then we'll go back and choose one. Okay? That's pretty good standard one, right? Fire potion, I like that, right?
Yeah.
Then we have a potion of strength.
Ooh.
Cool. That's not bad.
Yeah.
Complexit suggested that, and then false bracket suggests it says lightning sounds cool.
Lightning
Meme
sounds
Meister Game says I want lightning as well. Lewis Squid, hey Lewis Squid, I remember Lewis Squid from the last stream. I believe they won a copy of Power Wash Simulator when we did our dev interview with Power Wash Simulator.
There was a game called Power Washing.
There is, yeah. They were on our stream. It's quite the game. It's an awesome game. It was just released last week. Check it out. Then there's a Unity potion. This is what they suggested. And then there's a Flash potion suggestion. Mm-hmm. They want the Unity potion to be full of 3D gizmos. Maybe a Splash potion of ice by NPKNT. Oh, I like Meme Meister Gaming suggests a wind potion. That's pretty cool.
Wind potion.
Wind potion. And then BIP420 suggests a Cauldron potion. Which we could make. We could make a Cauldron potion. Maybe we'll do that at the end. We'll make a Cauldron potion.
We'll put a Cauldron potion at the end.
We'll make a Cauldron potion. And then there's also a Void Energy potion. Okay, so what are you feeling? Which of these? Ghost potion is pretty cool. I'm personally feeling Ghost, Freezing, Lightning, and Wind. I'll let you decide.
I'm probably gonna go with Void or Flame. I think Void is pretty cool.
Oh, Void, eh?
Void, yeah. Let's do it.
Void.
I think it's easily interchangeable with the setup we have right now.
Okay, so Void potion, Void. So what is Void? How would you describe Void?
Yeah, so Void is always like, if you look at like a game of Legends,
League of Legends.
League of Legends. Sorry,
Okay.
thank you.
No
League
problem.
of Legends, you have like some characters that use like these void abilities, and they're always like dark purple hues of things that just have like these bottomless holes around it, and like this.
And is it energetic?
It's
Or is it slow?
It can be energetic, or it could be like sort of like a dark hole kind of deal, like just more
black
like
hole.
Yeah.
Okay, black holes are usually chaotic and fast. Okay, so who suggested Void Energy? So Mr. Pickle 420 suggested Void Energy potion. So we're making the Void Energy potion. Congratulations, Mr. Pickle 420. We'll be reaching out to you. We'll have you fill out a form and for the Unity minifig. Okay, so let's do that. Let's make this Void Energy potion.
Let's do that. Okay, so we're still gonna use the asset packs. Okay. Let's actually rename this to Void Energy.
Yeah.
And we're actually gonna look for maybe something that looks more like it would be like a Void Energy kind of deal.
Yeah.
Let's look through our hero assets. This doesn't look like it. This doesn't look like it.
That skull. Oh, the spider or the skull.
The
looks
skull
like
or the spider. You want to do with the spider?
Yeah, let's do that. This is gonna be our Void Energy. Spider Void.
Let's do the spider.
Dark and purple.
Yeah.
Okay, so first of all, green is more poison, right? We gotta make that more purpley.
Yeah. But before that, let's just adjust our pivot slightly so it's more centered.
Yeah.
Oops. Just want to like put it here. It's always like minute like changes. Yeah, let's make it purple. Let's make something like you would see in Dishonored or Syndra in League of Legends. By the way, this is just like really on the go, but yeah, got something here. And also these bottles, like you probably wouldn't see that in a void void potion. So you know what? Let's change the output particle mesh to something like output particle quad, and we're gonna use quads instead.
Sure.
And Whoa, okay, we're getting like, actually, let me just duplicate this one. You can duplicate
Process
context.
isn't always pretty, guys. The process isn't
Yeah,
always
yeah,
pretty.
process is a messy thing. You can duplicate, by the way, your context if you want to keep your operators, and just right click on it and convert output. And then you can choose a different output. In this case, we want like quads. Probably want them opaque. We just want to cancel out whatever output particle context we have here. And we want to hook this one in. Let's hook this one in. Oh wow, we have like a random texture on this. Let's put particle this. Also, let's cancel out the rotation because it's kind of messing up our stuff. And let's make it face the camera plane.
So it's the billboard effect, so it's always gonna face us.
Yeah. Right now, it's getting us
big,
this.
and it needs to be transparent.
Yeah. Let's.
So what did you change just now to do that?
I basically checked alpha clipping, so I can clip the dark values of the texture. That's a good way to, and then you can modulate it also a bit, like the alpha clipping you see here.
Yeah.
And we're also gonna like tone down the size a bit, and this also we're gonna make it like really purple.
Nice.
All right. So now we have something that's popping in and out like dark matter, and we can make it more interesting. Let's duplicate this context, and there's something really cool for like distortion effects in Unity called output distortion quad. And this creates like, if you hook it up as well, oops, output, oh sorry, is the strip one, careful. You don't want to use the strip one. Strip one is for another time, another episode. But you want to use just the particle distortion quad. There you go. There you go. Oh wait, my bad. I'm messy. I want to have it to do with this one.
This is looking good, really cool already. I love how can't wait to see what you're gonna do with these little particles.
Yeah, so particle distortion quad, what it does is that it layers in like a distortion mask to blur what's behind it. You see that we're getting some blur effects behind it.
Yeah.
And you're gonna see here that maybe they're not blurring the stuff here. And I'm gonna show you guys a cool thing. If you go into Potions, your graph itself, your graph asset itself, and you zoom into your specter, you can see the output render order. So you can actually specify in which order these things are going to be rendered. In this case, output particle distortion quad, we wanted to maybe render it first. Let's see how that looks. Or last. Probably last. Just to make sure that the order is okay. And we also want to have a distortion scale. So in this case, we're probably going to like play around with the distortion we have here.
Oh, that's cool. Okay.
Yeah. And we also want to probably use like some alpha thresholds and maybe spruce down the side a bit. And it's using actually a distortion map, in this case the default particle texture.
Some people think that the purple we chose is the no texture magenta.
The no texture magenta?
They don't know it was intentional.
Yeah. Well, I'm having maybe some issues with this. I'm gonna try to put it here. Because like clipping. Maybe actually...
Well, I mean, it does look a bit chaotic, so I think it looks pretty cool. But I'm starting to see the distortion behind.
Yeah. Can't get it to work right. But anyways, you can add some distortion with this output render node. And if you stack them on top and just increase the size on it. Notice here that we're still seeing the edges. Don't mind this. You can actually eliminate them if you have a proper map. I'm just using the default one. But you see how there's like some slight things happening there. And maybe we can reduce the output color here and just get like some...
There we go.
Something much
no
more
longer
nice.
the no texture magenta. And now I think what we should do is make the rotation like spinning wildly rather than just this slow spin. Like this madness void kind of thing. It's spinning in the void.
Yeah. Do you want it to spin like faster? Just
faster and in more... yeah, let's do faster.
Yeah. Cool thing about operator blocks like parameters is that you can actually do like basic arithmetic in it. So I can multiply things by 2 inside of them. Oh wait, I'm actually just modifying it in the wrong way. This was the small sparkle particles.
Right.
We need to go back into the main object. Yeah.
So this is affecting the actual potion mesh right now.
Yeah. Let's multiply by 3 on each side.
Okay. There we go.
We can multiply even more further. Let's do that.
Yeah, let's make it super noticeable. There we go.
Yeah.
That's super cool. Okay. There we got more of a void portion going on. Now what should we do to the glow?
The glow?
At the bottom, should it be growing even larger, or do you want it to be rotating and spinning and
Oh yeah, good idea. Actually, if you want to push past the constraints of like the growth, we can, notice when we had in this like the glow ground system, we had a scalar to multiply it, so we can just boost that up, and you're gonna see it's glowing even larger.
Oh, amazing. It's so simple to just do that.
Yeah, very easy. That's the nice thing, is that you can go back and quickly author things or duplicate stuff. Or notice I changed a lot of these things into like absolute parameters, but the ideal way is to convert them into properties and make them more authorable.
Right.
Always think about your fellow artist and make his or her job much more easier at the end of the day.
So I think that there you go. There's your. Can you do a cool? We already added some distortion earlier, Sarge, to the potion, but then we removed it after the fact. But yeah, I think we have our cool void energy potion here. Thank you so much for the suggestion. That was a great suggestion. I'm glad
It's really neat. Yeah,
it's really cool actually. We pulled that together pretty quickly.
Yeah.
I think we can move on to our next section, where we're gonna move on from potions, and we're gonna talk about another very important principle of visual effects, which is the fundamentals of noise and randomness. And so how are we gonna do that today, Kodran?
So we're gonna go into, we did our example. We're gonna go back into like more theory, like just ground ourselves into what we're speaking about. Let me actually just save it. I don't know if I saved it or not. Hopefully I save it. Whatever.
Hopefully. Yeah.
So you see here, I showed you in the showcase and the GitHub repository this screenshot. This is actually a 3D representation of noise that you have in VFX Graph. So if I open the noise graph asset here, you're gonna see it, and this is essentially all the same graph with again a switch selector to specify which noise to use. If I go in from the top view, you're gonna see here we're using one-dimensional noise. Here we're using two-dimensional noise. You're gonna see it, it's like two-dimensional. Here it kind of looks like a 2D texture, and here we're using three-dimensional textures. So let me frame this for you. The reason why we're talking about noise is because noise is one of the essential things when it comes to visual effects. It's like your bread and butter, right? You move things with noise versus just like making them go straight in a linear line. So this noise really plays into fact when you're trying to do things like weather systems or small AI or in a particle system. And you can think of it like a channel, like a medium through which your particle goes through. So in the same way that an airplane experiences turbulence, which is the air molecules like wrapping around and then pushing it in all sorts of direction, noise does the same thing for your particles. It can be very intense, it can be very smooth, it can be very sludge-like with having a lot of drags if you're doing like underwater stuff like Subnautica. Or it can be very like, mild and fluffy, right? Like sort of like Last Campfire where these dust specks come into here. Right. And I really just wanted to visualize it for you guys. And in this graph, all the noise possibilities you have here. And these are all the built-in operator blocks. You have the 3D options here, the 2D options here, and the one-dimensional options here. For today, I just want to focus a bit on 3D because it's going to be very relevant to what we're going to be building with, we're going to be building with our weather system.
Yeah.
So I'm just going to like pull this.
Yeah, it's better we hide what we don't need, and so that for the sake of the compression.
Yeah, for the sake of
see the graph. Yeah.
So you see it here, still using the same thing as one of them. You have the property selector here, which selects between the one-dimensional all the way down to like the three-dimensional. We're going to stick to 3D for now. And essentially this is a voxelized grid of, let's see, 20 by 20 by 20. So there's a particle for each. And what this noise is essentially doing right now is it's modulating the size. So when the noise is denser, this has pockets of influence that are denser. It's going to influence into like the red gradient you see in some of these instances. Where it doesn't influence as much, you're going to see pockets of emptiness. And you notice that we also use it in the color with the gradient here.
Yeah.
Very useful stuff.
I think we should hide the noise texture because I think it's causing a lot of compression on the. So just show the graph for a bit if possible.
Yeah, yeah.
And then swap.
Actually,
Yeah.
I can probably scale it up. Would that help?
Yeah.
Yeah. Let's change a bit these things.
I think having the effect on screen while the graph is showing is causing compression overall. So
okay.
Yeah. So maybe hiding the graph. Hiding the effect while showing the graph.
Can I just add a bit more count so I can make it more denser? Maybe that will help.
Oh sure. Yeah, I'm not sure, but right. Okay.
Yeah.
Chat will let us know.
Yeah. Anyways, you notice this is a visualization of the noise traveling through this sphere, right? And this is the only stuff that I want you guys to like notice. It takes in a coordinate. In this case, it's the position of that voxel plus the time added to it, which is gonna be inputted into our coordinate here.
I think there's too much color change, so I think you have to hide the effect while showing the graph.
Okay, let's hide it.
Perfect.
Yeah. And yeah, you're gonna have like a couple of separate parameters where you can like influence, which is the frequency, like we see in the sine wave. Higher frequency leads to more granularity, whereas like lower frequency leads to more smooth wave. So this is where you can really author it if you want, like, does specs to move like in a smooth way, or does specs to move in a very granular fashion. And you can make it even granular by increasing the octaves. Octaves sort of like sample at a much higher precision and adds even more granularity to your effect, but at the cost of performance. And at the same time, you also have amplitude. So remember when we talked about the output range of values between -1 or 1 or 0 and 1, this is where you can determine that, how big of an output value you want in your noise thing. And this is what happens. I'm just gonna show it quickly, sorry.
Yeah.
Sorry for the question. But here's an illustration. If I increase the frequency, it's so jittery, right?
Yeah.
So jittery. But if I decrease it to something like 0.1, boom, it's like clouds suddenly, right?
So cool.
Yeah. And this is where I can put like even higher range of values. Like here I have what's it called? 0 to 1, but I can put it 0 to 6 even. You see like these are much higher values that are being outputted right now. And at the same time, you can increase the octaves, so the precision. Low octave, very dull, very primitive, very smooth. But high octaves, super granular. Now you're getting like, and you see we're tagging on performance a bit, but see it's super granular right now. So yeah, that's pretty much fundamental noise. Keep that in mind because we're going to use it.
Right. So now I guess we're going to jump right into the environment effect that we're making.
Yep.
So we're just like, if for anybody who was there at the beginning of the show, we were looking at the falling leaves effect in Ghost of Tsushima. There we go. We're going to do our own little autumn falling leaves. I believe they're maple leaves. Is that right?
Maple leaves, yeah.
As Canadians, we have to represent the maple leaf. So,
maple syrup too.
Syrup, right? And, so we're gonna be doing a noise effect on falling maple leaves. We're gonna add wind effects. We're gonna add turbulence and all these kinds of things. So we're gonna dissect that graph now.
Yeah. I just want to mention Hassan because we're using like asset store package. I mentioned that I usually like to build these effects being grounded with some assets.
Yeah.
This is I think from PolyArt is the Dreamscape Nature Meadows. It's a beautiful asset pack and allowed me to put this scene together in like 5-10 minutes or something.
Amazing, yeah. So you just pulled some assets out, some prefabs out, put them together, and then layered your visual effect on top of it and kind of made your own scene, right?
Yeah. Like get some sort of a stylized Ghost of Tsushima,
Great.
thing going on.
And that asset is on sale right now. It's 50% off for our Discovery 2021 Asset Store sale. We're going to drop a link to the entire sale in the chat right now and a link to the Dreamscape Nature Meadows asset itself in the chat. And so, yeah. Go ahead, Kodran. Let's jump right into the graph.
Absolutely. So, I mean, although we have this setup here blended perfectly with our trees here, if you take a look around, right, you're going to see that it's kind of like a box shape. You get a lot of these things spawning only at the top and changing directions as it's falling to the bottom. And we're going to illustrate that a bit more by going into what is our sample scene here. So, because this is very undistracted. Which is what I always encourage when working with VFX Graph. Make sure that you have an environment that is easy to debug. Otherwise, you're gonna curse at it. You're not gonna have fun. Yeah, let's jump right into it. So this is the autumn leaves graph. So you see it's a system with a lot of operators outside of it. We're gonna have to think a bit about this, okay? Because this is a more involved weather system. And you're going to sort of have to ask yourself at the beginning these questions, because you can't just jump right in and produce it. You're going to have to like think about how these particles actually behave in space. Now, as Hassan pointed out when we're watching Ghost of Tsushima, obviously these particles are going to fall from somewhere. So ideally from the top. You don't see leaves falling from the bottom up. So we're going to make them spawn at the top, which is what we're doing here actually. We're using like a random number generator on both the XYZ, but the Y component is going to be clamped up, so it only has on the top part of it only spawns at the top part of the box. Now we're going to combine them into a vector and set that as our initialized position. On top of that, we're also setting a bit more of a higher lifetime for our leaves, because those are not things that are going to despawn right away after 3 seconds. So we're being a bit generous, bring a bit 28 to 35 seconds. Same here, we're assigning a random velocity, sort of like a bias, because nothing is too perfect in nature. Nice to add some sprinkles and variations here and there when you can permit yourself. Be careful though not to overcumber yourself with too many things that are become too hard to debug. Do it at every step of the way, do it step by step. And because we're using assets, in this case, we go in wireframe, we're using sort of not a quad, but our own custom mesh with a custom texture, because you're gonna see here, we're outputting to a particle mesh with a custom shader. We're also going to have scaling issues to worry about. So whenever, like I said, whenever you're working with meshes in Unity, especially VFX Graph, you're going to be working mostly with scale as opposed to size. And scale is a good way to just specify that, because these are going to need to be rescaled based on your import settings. So if you don't see anything, scale your assets. Easy way. So yeah, we have this initialized condition set up. Now we have to think about, okay, our particles, let me just show a case without the initialized conditions, what they kind of look like if we just put them here. So now they're just moving with the random velocity. If I turn that off, it's just going to stay static in place. So this is our small bias. It's going to be biased to like, shove in that certain direction. We also know that particles fall to the ground, not up. They don't stay static in place. So lucky for us, built in within the VFX graph, we have something called gravity, a gravity node. So we put that at runtime. Anything that's like force related, you should put that on the update context.
Because in real life, gravity is a force that's constantly being applied to you.
Great point, actually. Great point to mention that, yeah. And yeah, we always want to have a force of influence applied at all time to our dots in space, our particles.
Yeah.
You notice that they just fell into oblivion, and that's not looking very interesting. So we have certain things to collide with in VFX Graph. And because VFX Graph is a GPU bound tool, not a CPU bound tool like Shuriken, we get primitive colliders. In this case, just planes, cubes, circles, but don't expect like very overcomplicated mesh to collide with, right? Because that's way too expensive to put on a million particles. And in this case, we're just using collide with plane.
We just need a ground for the leaves to stop on.
Yeah.
We don't want them to just fall into the void, right?
Yeah, totally. Yeah, and this, we have a node called collide with plane, and we specify that position -5 on the Y. We don't want as much of a bounce, so very small decimal value.
Maybe show how we can quickly just raise and drop the plane. And how...
Okay, yeah. So if you go here,
yeah.
Boom.
So we're just changing the height of the floor. So we're gonna line it up with our Nature Meadows asset set, right? So it's gonna be on the ground of that asset prefab we're making. Right?
Yeah. You're gonna want to
Create
be
the illusion of it landing on those assets, essentially.
exactly.
Yeah.
Always think in terms of illusions, like we did with the glow, right? You
Right.
want to match that up to be matching with your ground level, your ground mesh.
Exactly.
Yeah, and you're gonna notice here that if you have a ground mesh, you can also take in and put the normal, so they have like more, undulation on them. For
We
this
have
example,
a good question from 3D Polyrath. How do you handle rain where instancing needs to happen at the floor? So I guess they're talking about when the rain particle hits the floor, it then turns into another effect, which is the ripple. Maybe just quickly, if you can just quickly brush over like
yeah,
the logic
so
behind that.
for any of you viewers that don't know what he's referring to, rain particles when they hit and you see in games, they have a splash happening here, almost as if it's in sync with the ground. But coming back to what we were talking about, that is still all an illusion. In fact, that is not a particle system that you see on the ground splashing. This is just a shader, most likely than not, put on the ground level, very separate. But a shader plus a VFX graph kind of yields that illusion, right?
Right.
Because to do that, to instantiate everything is going to add more burden to our particle system here. However, there is a way where you can do that, and this way is called sub-emitters.
Yeah.
So up until now, we've been working only within this one system, but systems can be interconnected and cascade into each other. Like you can add a node here called event on die, and then you can connect it to another context, which is a GPU event context. So that means that when it dies, it triggers this the system, and then you initialize particle, and then you can build your own graph, like a splash. But I'm not going to go too much into the splash, but a very good question, and this is how you do it.
Yeah, so you don't actually need to do that though. You don't need to make the sub-emitter. What you can do is think in this idea of it's like smokes and mirrors, illusions. Game dev is like just you're making these illusions, right? And so you have two separate systems, one of like the falling rain and one of ripples on the ground. And our mind just connects the two, right? We just assume that, oh, these rain particles are creating these ripples. You're not, players are not going to follow each raindrop and see if it's landing and creating a ripple on the spot, right? You're just going to connect those two things together. Yeah. And you can save yourself a lot of, it's a more optimized way of achieving this.
Yes, absolutely. Yeah. I always think about optimization. You don't need to recreate things 100% realistic because remember, we're working real time. We don't have a render farm. It has to fill it into a platform at the end of the day.
Yeah. Sorry. Go ahead. Continue.
So yeah, you have bounces. We have like a small bounce, like just to buffer it up a bit, but you can eliminate it as you wish. Friction. Sometimes you want to be friendly with that parameter because if you like turn it like crank it all the way up, like you might get some interesting results or unwanted result depending on what you want. But we're gonna keep it low, not too much. Another one important one is lifetime loss. So as that stipulates that what this attribute is for is when it hits the ground, it tells you the rate at which it's going to lose its lifetime. So if you have like 20 seconds left, and when it hits the plane, it can erase like 90% of its lifetime. And this is what the slider is. Like in this case, we're probably erasing 77% of its lifetime, just so it can despawn faster, so it can spawn more particles. And like in Ghost of Tsushima, the particles are not accumulating on the ground, right? There's always like meshes of piles of leaves, so that way you can despawn these particles underneath those piles. So smoke and mirrors again.
Exactly. Yeah.
We're just gonna add a bit of rotation here. Always think in terms of variability, so you see much better, not just flat.
Immediately. Yeah.
Immediately, right? And this is where we get really interesting because we talked about noise and randomness. Now there's two ways of achieving this: inside the context or outside the context. Inside the context, we can use turbulence. And I mentioned to you guys, turbulence is one of those things that you could really use in practically anything. And you see here it being used. Now it's slower. Now it's like much more shuffly as it goes going down. And this is because we tied the intensity to the distance of each particle's position to the ground. That means that we can simulate like a current that's passing through like the ground itself. So particles fall much more linear at the top, but they get more shuffly towards the ground. And this kind of helps it sell in a way. You want to think about how does your particle evolve as it's traveling even linearly on a one dimension, right?
Right.
And this is where we can actually achieve that, right? We can increase it. Let's make it more shuffly as it falls
It's
to the
like
bottom.
this more turbulent wind.
Yeah.
It's telling us something about the medium that these leaves are flowing through.
Yeah, you always have to think: is it water? Is it space? Is it just a small breeze of wind? And I illustrated to you like the frequencies. This is what you can do actually here: frequency, octaves, roughness. This is where it's useful.
Yeah.
Visualize your noise.
We have a user asking, how would you handle particles that go up? So I mean, maybe we can just quickly illustrate that by changing the gravity to negative or something. Can we push?
Yeah,
Can we just
absolutely.
send the particles upward? It's like not really very complex, I think.
Yeah. So now we have a gravity on the y-axis up and down of -1, but let's just put it up.
Yeah, there you go.
So there you go, man. A really good question, actually.
They were looking for the example of like steam floating up and hitting like the ceiling, right? So that's you would just have to change the effect, and you could achieve that as well. Yeah.
And while we're at it, right, sometimes you wanna achieve like this cool looking like space stasis effect, like where things are just floating slightly, moving slightly, but not that much. And we can do that by actually increasing the drag on our system here. Like we can make it like sludge in a way, like just it's barely managing to get through that field, that medium.
Right.
And now you can see like maybe like the space station blew up and leaves are falling right now in some random direction, but some are just static in the middle. And yeah, you can do that. Noise is your friend. Noise is bread and butter here.
Yeah.
Now, I talked about noise in turbulence in the operator context. In the operator called turbulence, but you can do it also like we've been doing in the example I showed you with all the different grids where you visualized it outside of it. And this is exactly what we're going to do. So we're going to do the same thing, but just outside of it. So in this case, we're not using it right now, but we're going to take the position, and based on each position, it's going to read like the grid noise values. That's why I plug it into the coordinate. And then we have the same parameters. So we have a 3D curl noise. We have frequencies, octaves, roughness, and amplitude. And this
maybe we should hide the particles on the right as we're going through the graphs, just so that it's easier for people to. Yeah, that's great. And then, right away it's much clearer. I just want to let just a guy asks, is this a built-in feature in Unity? Yes, we're using VFX Graph right now. It's built into Unity in the URP and HDRP pipelines of Unity. You can use VFX Graph.
Yeah, absolutely. It's the future for visual effects in Unity, and it's only going to get better from now on. And you're going to see as we go through. Very good tool. So yeah, back to where I was saying. Very good question as well. Yeah. So remember when we put the coordinates into the sampling of the noise operator here, in this case, value curl noise 3D. If you want to make it shift also, we can use the built-in operator called force, and just basically plug in that noise into the force here. And if you put back the scene here, you're gonna notice right off the bat some different effect. And still the same, right? It's shuffling around, but because we're using a different noise here, it kind of looks a bit different. But let's make it more smooth. Let's make it like very, very dull. Like remember we talked about frequency, very smooth frequency right now. If I increase the frequency, much more jittery, much more scattered, right? And I can tone it down a bit more, or I can make it go like super, like it's like it's like a leaf blower.
Amazing,
effect.
just by increasing the multiplier on the.
Yeah. Remember, this is all stuff you can use, all provided for you as well. I'm just trying to make sure that everybody understands that really the sky is the limit, and this is how you should think about using noise. Noise is your ally. And yeah, you can also do interesting things with by inverting whatever the multiplier is. And remember, we have a normalized value, which is the distance between the particle's position on the y-axis to the collider plane. And we normalize it. That means we convert it into a value between 0 and 1. That normalized value, we can use a 1 minus, essentially 1 minus whatever is outputted there to invert it. And we're actually kind of going to do that a bit, right? Let's invert it, see what happens. So now you see it's completely different a bit. Or let's just put it here. It starts off slow and it falls in much quicker. So if you have things like, I don't know, rain, for instance. I don't know if I can put it here. Actually, no, hold that. Wrong one.
So we're going to increase the turbulence the closer it gets to the ground. Is that what we're doing?
Actually, no, wait. Let me just scrap that. Sorry. Yes. So I remember I talked about inverting it. We can plug it in and remap the values. So in this case, to influence gravity. So now gravity in the negatives are always going to point downwards.
Right.
So we can make a point like, okay, what if I want it to behave a bit like rain? Like seemingly it's dripping from a ceiling. So it drips slow, but then it falls really quickly.
Right.
So notice we have it plugged into gravity this time. We disable the turbulence and the force here with the noise. And just basically basic distance thresholds can yield a lot of these cool things you're going to see. So we're just going to like really accentuate that force here.
And you kind of see at the start and then faster at the bottom.
Yeah. So now it behaves slightly more like rain. I mean, obviously a bit too much right now, but let's just put here. All right. Kind of like it's dripping from the ceiling. So just using basic distance thresholds on the Y value and different noise values, you can have multiple definition of what these leaves are. You can have them be defined in a space setting, in an ocean setting, in a how can I say, or just outside, whatever your wishes are, really. Yeah, that's it. And for the output, you just got like different textures applied to a custom shader. You can make custom shaders in Shader Graph and tie it into this. Just make sure you have experimental blocks enabled. It's all in the VFX documentation, VFX Graph documentation. And yeah.
So I want to ask the chat, what do you want us to make fall from the sky, right? So right now we have falling leaves, right? And we want to jump into the audience participation section of this, where we take some of your suggestions as to what you want us to change this. Pinolan says cats and dogs.
Oh,
Complex, that's a good one. Complexity says snow. We have toasters. Unity Tech says men. It's raining men. Okay. I don't tentacles. All right. I'm loving this. Glass. Oh my god, that's painful. Snow that builds up when it settles. That's a great one. By Sigil. 82.
Yeah, snow
Flower
is always
petals. Good. Italian Ace says girls. Medic says hot dog. You wish Italian Ace. Complexity says dogs. NPK NT says fish. Set fire to the rain like Adele. Oh, interesting. Wonder if we could do that. Lightning. Acid rain. Stars like a warp speed effect. That's really cool. Eggs. Okay, these are all great suggestions, but personally, my favorites are the two men and then raining cats and dogs. We gotta do that. So one of them was Unity suggestion and raining cats and dogs. Who was that? Who suggested raining cats and dogs? Peon Lan. All right. So I think the second minifigure prize gotta go to Peon Lan, right? Like that's such a great suggestion. So we're gonna reach out to you, Peon Lan, for that second Lego minifigure. Another reminder, next Monday we're doing another stream with the Royal Danish Library, where we're going to be playing games from the Lego Ideas Contest. And so look forward to that on Monday. And we'll be giving away more Lego minifigures on that day on Monday. So that we've just given away our second minifigure for the stream. Congratulations, Peon Land. All right, so let's jump right into it. Let's turn it. What do we want to do first, men or cats and dogs?
We can do men and cats and dogs after. Let's do that.
Let's do it. It's raining men. Okay, where are we gonna? What are we gonna do for men?
Let's first go back into the forest because we have to brush it up a bit. We have to settle into the most suitable environment.
Oh, right, of course. You need men to fall from the forest. That's right.
Exactly. We get this. All right, so obviously we're using like a mesh with a texture in it, but a while back I'd scanned myself, so I think I used it in the burning object or point cache stuff, but I guess we can use it here as well. It's gonna look weird. It's gonna be a scan of myself in a way. But first let's detach these and let's worry about particle count because we don't want to crash our editor.
Hey, Sereno says, could you make it look like men dropping from trees? Yes, that's exactly what we're gonna do.
Okay. Yeah, we could.
Megamani
Let's
says,
actually-
hallelujah. It's raining, man.
Hallelujah.
We're waiting.
So I just reduced the particle count right now to 32 because I'm about to use a high resolution mesh. So keep that in mind. If you use too many particles with high resolution meshes, you might crash your editor. Okay,
Alright,
just
cool.
be very, very friendly to your editor. Okay, don't abuse it.
No.
It's tried its best to do things real time.
Your editor cares for you, so you should care for it.
Exactly. Okay, so we have capsules right now, but you know what? Let's where did I put? Let's change it to opaque. Yeah, let's eliminate this texture. Let's not use this texture. Yeah. Well, this is the mesh of myself I was gonna use for like the point cache, but I guess I could use it here. Yeah. Can't see stuff because I
Okay.
still need the texture.
So we've got a mesh in there, but we need to stop. Oh, there we go. I wonder who this is.
Yeah, I mean, it was supposed to be like a nice reveal for like the next scene, but hey, we can use it here as well. Obviously, these
bit
are
too big right now.
huge.
We gotta-
These are oversized.
Let's
Yeah,
minimize it.
let's
And maybe we can show off who it is in the next.
remember I said use set scale.
Chad is loving this right now.
Let's put like I don't know, maybe like change the scale to like 1 or something.
Okay.
Oh wow, wait. Actually, yeah,
It's looking good right now.
it's looking good right now.
go.
Yeah.
A little widespread.
Yeah.
Maybe
You know what?
bring it all closer together. The emitter.
Yeah, I guess. Do you want me to make it smaller? Or
Yeah, I think we should make it smaller and closer together.
closer together. Okay.
Yeah,
Yeah.
so that it's actually all coming from the trees.
Yeah. Let me just like scale it down a bit. So.
There we go.
Go here. Oh my god. Okay.
Alright.
And let's actually reduce the bounding box size so we're much more focused here.
Yeah, make sure the floor plane is aligned with the actual ground.
Yeah, you're right. Man, I forgot that.
Again, it's all illusions, right? It's not actually hitting this ground mesh that we've set up. We're setting the actual ground plane as in the operators within one of our systems.
Yeah. Yeah, there we have it. Yeah, and maybe you can be more playful with it. Let's add a bit more of myself.
Yeah, there's not enough cauldron.
Not enough quadrants. Let's we're 64 right now. I mean, this is the limit
Great.
we're gonna set. Okay.
And you know what? It's not realistic enough to me. Like, you're flying through the ground. I feel like you should be, you're a bouncy guy.
Yeah. Yeah, you're right. You know
You
what?
should be bouncing off the ground.
Maybe we can do that. That's not a bad idea. Let's do that. Let's make it very bouncy away.
Okay.
Let's see what that looks like.
Perfect.
Maybe a bit more, just for fun. Yeah.
Yeah, and I think we need to get showered in cauldrons right now. So I think we need to set the camera under the tree so we can see so we can actually have raining men on us.
Yeah. Oh.
Come on,
okay, yeah.
let's go. More raining men. There we go. It's raining men. Hallelujah.
This is so weird, and this is the thing about like.
Welcome to the
VFX
Unity VFX stream. Principles of visual effects with VFX Graph. We're very serious over here. It's very only serious visual effects.
Only serious work.
Serious work only.
Oh, cool. This is a nice shot actually with like the volumetric light. Oh man.
Waiting for the demonetized dinosaurs.
Because we're using HDRP right now. Okay, it's we got some
Yeah.
fog here we can play with, but yeah, man, it's
Wonderful. Okay, so should we jump right into the next suggestion, which was cats and dogs? So let's show how we can easily swap these meshes out and throw in some cats and dogs into the mix.
So unfortunately, sorry to the user who's just a cats and dogs, but I do have like hamsters, bears, and belugas from an asset pack right now.
Okay, so they suggested animals. We like the suggestion. We're not changing the winner, but we will. Do you have frogs? Hamster is good.
Frogs.
Hamster's good.
Do you want frogs? I guess I can retexture a frog a bit. Let's see if. Oh no, we don't have frogs.
Hamster's good. We're good for hamster.
We're good for this hamster.
Hamsters and whales are the perfect replacement for cats and dogs.
Okay,
Come on.
let's
They're
do
basically interchangeable.
interchangeable all the way.
So
we're just gonna find its mesh.
Yes, this is a very cute little hamster.
And we're just gonna replace it here.
Could you remind us which asset pack this was from?
Oh, this was the quirky animal asset pack, the volume 3 actually.
Yeah,
It's
it's Quirky Series Animals Mega Pack Volume 3. Again, currently on sale, 50% off. It's got the cutest animals, a huge range, huge set of animals.
oh.
But no, that's fine, Bernie. Thank you. Yeah, so we're gonna post a link to it in the chat.
Yeah, but here's a run through of the model. I'm using it in HDRP, but I think you can easily use it in URP. I think it was made for URP actually.
Yeah.
But I just put some unlit stuff into it, and let's find its textures, its skin, and put it here. So now, if we exit this prefab, we should have raining hamsters, but I guess they're not scaled properly. Okay, we're gonna need to scale them until oblivion.
They're coming in.
Yeah.
Oh, it needs to be even bigger than that. There we go.
Yeah.
No animals were hurt during the recording of the stream. Promise.
So yeah, we got some hamsters floating around.
Can we just full screen this and appreciate this for a second? We need to.
Yeah,
like
absolutely.
Oh, yeah, there we go.
Let's go with this. So
what are we doing? What are we doing right now, Coach?
I don't know, man. It's I think it's like fine arts right now.
Yeah, exactly.
We can showcase this into like I don't know, the existential crisis of the.
This is what we do
hamsters.
for a living, Codrin.
The eyes. You mentioned the eyes. You didn't like the eyes, Hassan, but I mean, you know.
You know, I like the eyes, but when all the animals are staring at you at the same time, it's a little scary.
Yeah.
Because they all have the same eyes, you know.
The fruit of the tree. Hamster.
Perfect.
Hamster tree.
Okay, thank you for the suggestion, Pyeonlan. We're gonna jump into our next section, which is we're gonna be using texture as data, and I guess we're gonna be talking about point caches, and we're gonna be setting things on fire. So I'll let you take it away, Kodrin. This is gonna be an interesting one. We're jumping into a new scene now.
So yeah, gonna go into it right away, but just to reiterate, you can see how we went from leaves to bouncing hamsters. Stuff is just versatile as long as you modify a bit of noise and gravity. But yeah, let's move into textures. I guess I want to save it, yeah. I'm kind of grew attached to this. So remember when we showed this, let me just bring up the graph here. All right, so this is a graph corresponding to this. I'm just going to go to a quick flyby of this. What you have here is actually a bunch of cubes making a terrain based on a height map texture. So we're using a 2D texture to sort of spawn a terrain made out of cubes in VFX Graph. If I like slow down the cube size a bit, like you can see very clearly, it's like small cubes just making up a terrain based on a texture. But let me get into why we're talking about this first of all. Okay, so a lot of times when we saw the effect in say games like Death Stranding, right? These dots you saw that we're telling you where to walk, where not to walk, where you can trip and not to trip. They had to the creators had to assign that position somehow, and most likely they used textures or what's called point cache. So these are two methods that I sort of want to like show you guys out there that you can have more leeway into art directing your visual effects and create some things that just follow silhouettes, that follow landscapes, that follow animation meshes, right? There's stuff that does the same thing called skin mesh renders, which is a new feature in VFX Graph, which I'm going to go probably in the third episode. Static mesh samplers, which do the same thing but with static meshes. And you also have point caches and a point cache baker tool into the in the engine itself. Now, we covered why you would want to use that. I mean, obviously you can generate terrain, and we're going to notice how I can use that to like make like burning meshes, like burning cars and all this stuff, to make like the particle system really follow the silhouette of things you're wrapping it on. But yeah, point caches are essentially two words: point and cache. Cache is just a fancy word for storing. So you're storing points. That's what it is. You're taking a mesh, you're taking its vertices, you're sampling these vertices randomly, and you're storing them somewhere. And in Unity, you have what's called essentially, let me just say, a point cache file, right? And within these point cache files, you have textures, like position and normal textures. And this is what it essentially is. You encode the XYZ value of that vertice into an RGB value of a Unity render texture. That's what's happening. That's all we're doing here. You can do that with PNGs themselves, although they'll be like very low resolution sometimes, which is what we're doing right here actually. So we can give it a quick run through with the graph. And it's very simple. Like, I mean, it's a bare bones setup. So our intent here was to create like a voxelized world, like a topographical map. You can replace obviously these cubes with like rocks and stuff if you want to scatter them procedurally, or have some interesting trees or that fade with a character or something like that. You feel free to use this as a procedural tool. But yeah, we first spawned our positions in a 3-dimensional grid. So we have 1024 by 1024. That is the resolution of our current textures that we have inputted into this. It's good to match up whatever the resolution of your height map is going to be. And based on that resolution, we can multiply 1K by 1K, and this will give you our total particle count, which will spawn one shot, and they'll stay there without a lifetime. They'll be just still living in perpetual until we tell them to die, essentially.
Yeah. I think it's a good time to mention that like everything you're working with here is available on your GitHub repository, and we should drop the link into the chat. So all of these example effects are currently available on Codrin's GitHub repo, but we're also gonna be putting them up on the asset store as a VFX Essentials pack with everything, with all the effects we've made today, excluding the third-party assets, of course. And yeah, and though you gotta get those separately, and we're gonna be uploading it as a VFX Essentials up on the asset store. So yeah, check those out. So yeah, we'll get right back into it.
Yeah. So yeah, all this freely available, and like I said, we're gonna add some more. This is a work in progress. It's always gonna be updated. Stay tuned. It's eventually gonna ship to a package. And yeah, good point, Hassan. Thanks.
Yeah.
So yeah, we essentially just want to spawn them according to an X and Z. Just to let you guys know a bit, we're going to go into the inspector here, and we're going to see which height map we're using. We're using this one. This is like an open source tool that you can navigate on your browser and take a height map field snapshot. And I think it's available somewhere. It's like a JavaScript thing, but we just took a series of mountain, right? And this is what we're representing. This is what you're looking at right now. So if we look like, top down. Yeah. So the way to sample, a pixel on your texture, obviously you want to have a property that where your texture is at, like a 2D texture asset where you can plug it in. You want to get the dimension. This is a built-in operator node in the graph itself that gets you the width resolution and the height resolution. And based on that, we can dynamically tell VFX Graph how many particles it should spawn. After that, we're going to use the same thing to one of our subgraphs. This is a custom-made subgraph, again, made by one of our Unity employees, Evangelist, called Keijiro Takahashi. And what this subgraph essentially does is that it takes that particle ID, right, which is one-dimensional. It can be from 0 to 1 million, depending on the resolution of your texture, and mapping it to the UV of your texture. So you're going to have 1 pixel per particle assigned to it. So there's no like confusion to it. And this is essentially what this subgraph is doing right now. It's going to be available also. Keijiro has provided this also in his own repositories, open source. And he basically all of his stuff is MIT licensed, so feel free to use them. Extremely great resource. Bless him.
Bless.
Bless him.
Woo, Keijiro! People recognizing Keijiro on the chat.
Everybody recognizes Keijiro.
He's pretty much Twitter famous, Keijiro, no?
Oh man, he's GitHub famous. This guy is
famous,
so
Twitter
prolific.
famous, prolific tech artist. Really.
Yeah. When I was working in Tokyo, I mean, I was looking up his repositories all the time. It was like I even had the chance to meet him at Unite Tokyo. Extremely nice guy, but very great work ethic and just an extremely good graphics engineer. This guy knows his stuff. Seriously check his stuff out.
Love that he's always working on meetings. It's really amazing.
Yeah. And so what's going to give us at the end of it, out of a subgraph, is the UV. So we can plug this into a built-in operator called sample texture 2D and use that then to output like a grayscale value, in this case our R channel, which is represented by X, to drive the height of these particles. So if you notice, if I disable this, right, you're only going to get the colors here, but it's pretty flat. But if I re-enable it, boom, you get suddenly the height value. And you can scale this by adding a scalar multiplier here, just to emphasize it more. And play around with it. Same thing can be done with using the grayscale value to sample from a gradient, because remember, that is a texture. The value that you're going to get from it is between 0 and 1. You could do so many cool things with it, such as remapping it to color. And in this case, we have so many different ways of remapping it, right? You can just switch our gradients and create all these cool different presets you see here. Sorry. And yeah, this is essentially the power of textures, and using texture as data to start to have a bit more complicated, more refined effects. Sort of like the, Death Stranding. Maybe Sam is here, and maybe when he pulsates, sends that ping through script to the VFX graph. The VFX graph will handle like the visibility of this thing, like the points on the rocks and all that stuff. Boom. Right. And yeah, that's what I wanted to show here. I think we can move on to point caches.
Great. So let's jump right into that. We're gonna, I guess, we switch scenes to our post-apocalyptic.
Yeah.
Is that where we're going?
Yeah, we're going at post-apocalyptic. We're just gonna give our. But we haven't baked in any point caches here though. But you're gonna see we're gonna use point caches to burn some of these assets a bit later on. But I think for now we can go into this one. Yeah. And
we're gonna go here first. Okay, so this is the mesh we made rain earlier. If you didn't see it before, maybe you want to zoom in on the face and do the reveal of who the raining man was.
I'm not in love with myself. I'm not a narcissist. This is just the only open source asset I could use, so I can make it freely available. So I literally provided myself to you guys.
Yeah, Kojin has given himself for the sake of technical art. Yeah, he's given his entire body.
Exactly.
Could you zoom in on the face? I just want to show everyone how happy and satisfied you look to be scanned.
Yeah. Let me actually just disable this.
There you go. Look at that. You're just.
And this was
scan me.
some artifacts here and there, but nothing too crazy.
Yeah.
You should see what my girlfriend did with it. She made me crawl with the Mixamo animation.
Right.
Basically the scan was when I attended one of the Unite events. Some of the guys there were technologists, and they gave me a free scan. So I was like, oh, cool.
That's amazing. Okay.
Unite events are so nice. If you have a chance, please go to them. Such a beautiful
when they're
community
back on after this global pandemic, and we're back to having real world events.
Yeah, absolutely, man. Yeah. But point caches. Okay, so remember when I told you that you essentially can take a mesh and bake those vertice points into a texture. Essentially, this is what we did here. Let me just toggle this one off, right? We essentially baked my mesh, the vertices from my mesh, into what's called a point cache called myself, obviously. And we have different maps in here called positions. The process of baking this stuff and getting a point cache, this is all built into Unity. We have a tool, a utility, and I'm going to show you guys.
It's not an external tool. We have it.
It's included in your editor. Any new version with HDRP or URP should have this. You go into Visual Effects on the window. You go Utilities, Point Cache Bake Tool. Boom. This was made exclusively for this. So we're just going to put this over here. How do we bake this? So we can basically take our mesh. I guess I just have to find myself. Yeah, so myself model. You just take the mesh filter component and you drag it here, all right? And it's gonna give you a couple of baking options. You can choose to export the normals, export the colors, or export the UVs, but we're not gonna really use much of that. I'm gonna leave it like this for now. And you can specify how many vertices from that mesh you want to sample. Obviously, the more you want to sample, the more refined, the more points you're gonna have on the mesh. The lesser you have,
so they're not seeing what you're doing on the screen. If you could just center it, I think that's the way we framed.
Yeah.
framed it. So maybe you want to show them. Yeah.
Yeah, like this.
Yeah, exactly. Please.
Yeah.
Yes, exactly. There you go, Chad. Yeah. See.
Yeah. Thanks for letting me know, Chad. Also.
Yeah.
So yeah, you plug it into the mesh component here, and it's gonna give you like a way to like sample it. So you can sample it randomly or sequentially. This is why you have like some random distribution here. And then after you're done specifying how many points you want to sample, you can save the P cache. In this case, I don't need to do it. I already saved it into my file, so I can just reuse that one. And this is the tool to do that. Now, I just want to go on a small tangent here. This stuff, right, is so useful when you're trying to do effects like you see in Demon Souls, when the character dies and you have these like, this like fade in of the character with like the silhouette of the particles. It's so useful if you played Resident Evil 8 Village. Amazing game, by the way, where you see like the sisters, Cassandra, Daniela, the morph and insects and all this stuff. This is done with using the same technique. It's done with a different variation called skin mesh rendering, which takes into account the animation. But we're going to see that later, but same principle, really. So used, overly used, very good. Yeah.
For good reason.
For good reason.
For good reason, yeah.
Because of what I'm about to show you right now, okay? So this gave us all these points, and in Unity you can get an operator called point cache where you can put the point cache here, right? And then the point cache, based on what you baked into it, you can get the point counts, where you can tie into the amount of particles you want to spawn. In this case, we specified 4K, so it's going to spawn 4K as you see here. And then it's going to give you the position. And there's a special operator node called set attribute from map. In this case, set position from map. And you just tie in that point cache to the attribute map. And it's just going to handle assigning for each particle the appropriate point cache position that you baked into your mesh. And so that's what you're getting right now. Now, sometimes your point cache, even though you did the baking correctly, you imported it like as it was supposed to be, sometimes it might be offsetted, all right? Okay. I'm going to show you a neat little trick and also a new concept here. You can use transformation matrices in VFX Graph itself. The node for that is called transform. You're going to see you're going to have so many of these, but it's transform position. And basically you plug in the current particle position and
people are calling this an outer body experience.
Yeah, upper body. You need to create this an upper body experience. And then you can shift it by minus 90 degrees, in which case I did it right now, right? If I put it back, that's how I offset it, because you don't want to rotate your particle system itself, because that changes your gravity direction as well, whatever you have in there. You want to do things through transformation matrices. And if you're familiar with like the transform component, this is exactly the same thing. You can do that. And then you can line it up perfectly. So don't worry about it. Yeah, then we sampled randomly. We just try to make these points, flashy so you can see them clearly. And this is the interesting part, is that these points, we're not going to use them just to like put them on the mesh itself, unless you want to, I don't know, you want to create a bubonic plague effect and all this stuff. Most often than not, you always want to use these points to emit from. So this is where you get into sub-emitters, like I mentioned. You can create an event here in the update particle called trigger event rate over time, maybe 24 times a second, and plug it into another system that is these particles you see here. And this other system, you can basically then create it however you want it. You want a Demon Souls effect? Cool, you can do that. This is how it's achieved. Basically, make these points invisible, but use those points you see on my body to emit from. And right. So those
particles are coming out specifically from these colored dots, right? That are on your body. They're not coming from your mesh or from the skin. It's just from those dots. We're creating the illusion that it's coming out of your body.
Exactly.
But we have control over the exact points on the silhouette of your mesh.
Yeah.
Great. And this is the point cache that we set up. Great.
That's a very good point, actually, because when I mentioned the emission rate for each particle per second, they're going to emit 24 of these particles. So each point is responsible for emitting at the same rate 24 particles per second. And you can see how this is an incredibly useful tool if you want to create or more intricate character effects, like in AAA games. I mentioned Resident Evil Village 8. And yeah, same thing with Death Stranding, same thing with Demon Souls, same thing for boss fights, like flames around the boss's back. Really useful stuff.
Yeah.
And yeah, that's pretty much it. I think I don't know if you want to have any questions or if you want me to move on to the burning object.
Let's see. Am I the only one who sees germ auras?
Yes.
This is what we see as we're walking down the street during a global pandemic. We just imagine the virus strains floating around the environment. Yeah.
Yes, visualizing COVID-19. Oh.
As Alice is crying. Mega Miley says Burning Man, please. Oh, okay. They're asking for the next part here.
Yeah, asking for the next
They
part.
want to see a Burning Man.
Burning Man.
All right.
It's not the festival, by the way. It's not. It's
It's literally
burning things.
Burning things. Okay, great. So what are we gonna do first? Are we gonna do it to this mesh, or are we gonna move into the next scene?
Actually, you wanna showcase it to this mesh first?
Yeah, let's do it since we're here.
Yeah. Since we're here, I mean, just want to showcase it. So basically, from all these points we gathered, we can actually now start burning things.
Man on fire.
Man on fire. We actually got myself burning here, but it's normal.
We just do it.
Because we now actually have access to the silhouette of the things we want to burn.
Yeah.
And this becomes so much more useful because we don't want to always place flame billboards here and there. Or if you have a complicated like mesh, you don't want to strip all these things onto that mesh. You sort of want to just bake it and emit from, really. And I'm going to introduce you guys to some new things here called flipbooks. Very useful. So basically, same setup that we had with like the germ setup. Just like the
new name, germ setup. And by the way, we just had a poll, and the poll question was, should we set things on fire? The options were yes and also yes. Also yes won. So we're gonna be burning things, setting things on fire.
Yeah. Everybody, lots of arsonists here, and a lot of games just have burning things for some reason.
It's very applicable,
Yeah, absolutely. But yeah, same setup we have here, except that we're now using flipbooks. We're not using spheres. We're just using sort of like a billboard that's going to be facing us with an animated texture on it. And the animated texture is going to be these flames you see here. Now, to get that set up, you actually need what's called a flipbook texture. And for those animators out there, you're going to know what I'm referring to. But for those who don't, can you rephrase that question? I'm not sure.
So how is the overhead for this type of pyro effect using VFX Graph compared to using a fire effect from the particle system? Like the built-in particle system.
Good question, actually. So the overhead, I'm assuming you mean performance and cost, correct? Mm-hmm. Okay. It doesn't compare. This is so much more performant. This is way like miles more efficient, and this is because of one key difference between the particle system and the VFX Graph. The VFX Graph is GPU driven. Everything you're seeing happen on here is in parallel on the GPU. GPU handles it. Right. Particle system is CPU bound. There's a limit, a hard limit. You cannot go past certain things, past 100 particles or 1,000 particles. This stuff, it will run fine even in the millions. So really, absolutely great way to use it. We're just using 1,024 particles because we don't have a need for that much, but we can up that up to an insane number.
Yeah.
Great question. Use this. I think it's such a good tool, and it lets you do more interesting stuff like CPU bound driven tasks like scripting, more complex behaviors. It frees up more bandwidth for that, and I highly hope more people use the VFX Graph in the future. But yeah. Flipbooks. So flipbooks,
as you said before, it's the future of visual effects in Unity.
Yes, I believe so. I believe that based on where Unity as a company is going, I think VFX Graph is going to catch up.
And that's not just for games, right?
Not just for games, M&E, movie and entertainment too. I mean, we saw Adam, we saw The Heretic, a lot of that stuff. All the VFX actually were done in VFX Graph.
Yeah, and as a like a technical artist, this must be like such a fun tool to play around with, right? Like just the artists who are gonna be in Unity all the time, right? Like using Unity and working within Editor to create their effects. This is like a playground for
yeah, No, much more fluid and less stressful. I mean, like when it comes to iterating fast, you can do it so much faster in VFX Graph than you could do in a particle system, because some things could be shared between one another, and this is the powerful nature. And you can share subgraphs and graphs to it's an asset even of itself. And it's, if you look at Unreal, for instance, Unreal has the Niagara particle system, and I don't remember the other one. They're essentially the same thing. It's, I think one was CPU bound, but now everybody's migrating towards Niagara because it's GPU bound. So yeah, like there's always going to be some more exciting features coming in for VFX Graph in the future as well. Like we have the product portal, and really it's catching up to becoming a very good tool. I mean, you can do so many good things with it and work with Houdini, with custom meshes. It's insane.
Yeah, and it's worth mentioning that everything we're doing and everything we did on today's stream was just directly in Unity. Like Kojin did mention Houdini just now, but we didn't use any of that stuff for the stream. You can, use this in coordination with Blender or Houdini or other tools, but for the purpose of the stream, everything we're achieving today was just within Unity, within the VFX Graph only. We didn't use any scripting, any coding. We're just in VFX Graph. So it's like you can just be a pure artist and build all of these things. You don't have to get involved with any programming. And we we brought in assets from the asset stores. So it's really very smooth and easy to jump into.
Yep, absolutely.
Yeah. Let you get on.
Yeah.
Keep going. Yeah.
So the flame texture we use here, I'm just going to zoom in here because I don't want to open up Photoshop again. But you see here, it's actually a flame texture animating, from on the x-axis up in here, and it's looping between all these like segments. It's like an animation sprite sheet in a way, and the resolution is 16 by 5. So when you go into output particle quad, you change your UV mode from default to flipbook blend, and then you adjust your flipbook size, and your flipbook size is going to be at the resolution at which you cut your sprite sheet. This sprite sheet is 16 frames long and 5 frames high, and so this is what you're going to specify here. You notice if I move this stuff, it's out of sync. It's I'm going to put it within the confines of that spreadsheet. And from then on, I'm just really essentially adding some color over live. A good trick in VFX, if you want to add some more variability, is by multiplying some individual color channels to have like sort of a bias, so it looks much more interesting, not just flat all the time. To have a bit more randomness. Randomness is your friend, as we saw. And we just set the scale a bit more random because we want it to be more wide to accommodate for how the flame in this case looks. And yeah, if you want to get your particle flipbook to play, you need a flipbook player. And a flipbook player, you always put it in the update particle, and this is what's going to play your animation spreadsheet. It's playing at a rate of 24 frames per second. You can change that up, 60 FPS if you need it. And another thing is, in your initialized particle, you also need to set your flipbook texture index. So at which frame each particle is going to start. I'm setting it randomly because I want more variability at which sprite frame it's going to start, not just all particles from 0.
Could we adjust so that we're seeing more of the graph and less of the effect? Yeah, and try to center the graph so everyone can see. Perfect. Yeah.
Let me put myself there.
Yeah. Great. Yes.
Yeah.
It's a little clearer for the audience. Yeah.
And so we have these things coming out of me. Now I'm just going to disable all the particles, and this is just from stuff being on my mesh on myself. And you're going to notice that there's another cool feature, because one of the first things you're going to notice when you're doing billboards on meshes is that you're going to see planes intersecting, and that's kind of an ugly thing. But within the output particle quad, there's something called use soft particle, and soft particle is going to use the depth of the camera to sort of like soften up the intersection between the quad and the mesh. So it's going to like have much more fading, and you can manipulate that by this value. Yeah. So it blends in much more nicely. Yeah. You mentioned, I mentioned before to you guys when I was doing the potions, the what's it called, the void potion, some thing that didn't quite work back then, but it was the distortion. And this stuff you can really use it if I plug it in with the flames to add more blurriness around them and kind of simulate that heat distortion. Obviously, this is for the sake of just these samples. I didn't go much into depth to creating these like distortion blur maps. But you can have a custom distortion blur map here and really distort the heat around you. So notice around the edges here. I'm just gonna resize this. Around the edges here, it's much more smoother. But if I take it off, it's suddenly
that's
sharp.
much more clear. Yeah.
Yeah, but I can put it to blur it and add some nice heat distortion to it. Now, also added another component to it because now we're using these flames, but we can also use the position of these flames to emit sort of like fire sparks or embers in a way. And so this is essentially what I did. I added an event here that triggers an event rate over time, 10 particles per second. And we had this this simple graph with some turbulence noise added to it to essentially produce some sparks running off the body.
Nice.
Yeah. And yeah, random lifetime, random velocity, and just a simple.
And so these sparks, just like before, are they coming out of the same points that the flames are coming out of? It's not coming off the mesh, just to remind everybody. It's coming from this point cache that you generated.
Exactly.
Is there a way can we revisualize that point cache? Is it still available to be revisualized?
Yeah, absolutely. So let's actually.
Just for anybody who might have just joined, they might get that idea.
Yeah.
There you go. So all the flames, these are all basically the spawn points for the flame effect textures and for the embers that are coming out. Here it's like a really intense amount of particles coming out, but for the embers that Kodran just set up, he it's a much lower emission rate. Because I mean, it's not really realistic for a fire to be releasing this many embers or particles, unless it's some crazy fire. Yeah.
Crazy, I don't know, oil fire or some stuff.
Yeah, this looks more like when you're welding something, the sparks that would come out when you're welding something, right? So yeah. Should we jump into our apocalypse scene?
Yeah, let's do that. So good opportunity for you guys to see something more grounded. And
we've set up this little scene for you. What pack did you use for this, Kodran?
I think it was the Apocalyptic World pack.
Nice.
Yeah.
So this is another pack that's on sale. The post-apocalyptic world pack. All kinds of apocalyptic assets like rundown cars and flags and destroyed buildings, bunkers and all that kind of stuff. All available in one package. Kodran, I believe you picked up random assets from within this package and you just put the scene together?
Yeah, I put it like yesterday, I think in like 10, 15 minutes. Everything here is made by me. I just quickly strapped some things around and made it work with a bit with perspective.
That's amazing.
But yeah, different cars. I kind of wanted this like, okay, this car crash and some pizza box there, some dumpster here, like here, Freedom Gate. But yeah, I was surprisingly astonished because this pack actually comes with a lot of LODs. It seems like a lot of the packs we use today features a lot of LODs, so really performance optimized. You see things changing.
They're really thinking about like game development with these packs, right? So, like if you're further away from the object, the level of detail will change to be a lower poly mesh, so that for optimization's sake, right? So you're not rendering all of these triangles all the time, right? So this pack is 50% off on the asset store right now. If you just joined, we mentioned that the Discovery 2021 sale started yesterday on the asset store. We've got a bunch of the top assets in 2021 that are on sale for 50% off right now, from tools to art assets, art packs like this. So go check that out. We're gonna we've put a link to the main sale page in the chat.
Mm-hmm.
It's back up there again, and so we basically used the apocalyptic pack, and now we're gonna set things on fire from that pack, right? So some of these unique silhouettes, because if we could just put like a flat plain fire effect and drop it on the car, but things might not match up perfectly. They might not clip. There might be some clipping. It might not look quite as good. So we really want the silhouette. If we want to light this car on fire, we want it to look realistic, right? We want the silhouette of the car to be on fire. So we're gonna have to do the same thing we did with your body, right, Kodran? Take this car. If somebody just joined, that would sound really weird, right?
That would sound really weird, out of context.
Out of context. We just lit Kodran on fire, everybody, in case you just missed it. So we're gonna turn this into a point cache, the car, right? And then light those points on fire. So let's do that.
Mm-hmm. So I'm assuming the car, right? We're gonna go for the car. All right, cool.
Yeah.
So we're gonna go back into the point cache tool. I mean, like I mentioned, and for those of you who just joined, by the way, I'm just gonna show it again. It's in Window.
Yeah, make sure to center it on the screen so people can see.
Yeah. Window, Visual Effects, Utilities, Point Cache Bake Tool, and I'm gonna center it here. And it's a tool that comes built within Unity for VFX Graph in particular. It really is meant to work with VFX Graph, and it's only going to get better. Mm-hmm. Visual Effects Graph team is an amazing bunch of people, really very supportive. And yeah, so our instinct right now is basically to take this mesh. Hold up, guys. I'm just gonna like close my blinds a bit.
No worries.
It's always like the sun scattering.
At this time of day.
It's like shining on my arm. I was like, oh man.
Yeah.
It's hot today.
Kodran doesn't actually like being lit on fire, guys.
Yeah. No, I don't like that much heat. Prefer winter most of the time.
All right.
So yeah, let's just select our car. You're gonna notice our car prefab is here, and we're just gonna isolate it here. We're gonna try to find its mesh filter, which is here. Okay, so this is what it will accept. SM equal car 1. Okay, and we don't really want to change the amount of points sampled. It's 4K is more than enough. Mm-hmm. Even like lower 512 is okay. Stick to, if you're not sure, stick to texture sizes, texture dimensions like 8K, 4K, 1K. Yeah, we want a random distribution. We probably don't want the colors because it's just flame. So we're gonna save it up. Gonna put it into our nice folders here. You want to make sure to stay organized. I have like my meshes, my shader graph, my textures, my subgraph, and my point cache, and they're all separate folders. And car on fire. I'm just gonna save it. And I'm gonna tuck that tab away. Go into our, sorry guys. Go into the VFX folder. Go underneath point cache. We should see that we now have a car on fire, and we baked 4K points, 4096, and we essentially just baked the normals in the position, and we're going to use that.
Great. We have a good question from Meme Meister Gaming. He says, they say I'm still missing the point here. Why use point cache when a shader outline / shader graph can do a similar effect?
So that's a good question, because there's a lot of things you would seemingly be able to do in shader graph, but fire, right? The outline effect, I know exactly what you mean. You when you push the vertices down or outwards and create like a different outline based on the Z pass, that's fine for most of the stuff you have, but you can imagine that fire doesn't behave like that in actual real world scenarios. If you have an outline like this and you just stretch it out as an outline and add it like a background fire texture, it's gonna look a bit weird. It's not gonna look like it's grounded in 3-dimensional space. It's just gonna look like it's grounded as a material. And so this is the nuance, is that if you, I think we have a reference here, I think, or maybe not, but if you guys remember, or if you play Red Dead Redemption 2, like the Molotov cocktails or the Molotov cocktails in a lot of games, you throw one in, it starts to spread, and it spreads, and as soon as it reaches like a threshold point on a silhouette, the whole silhouette catches on fire. And these are just points or billboards stuck on the object itself, and really plays a huge important role into selling that effect, because it's more grounded in 3D space. So they're very separate things. But it's good. It's a good point, because you might think you could use it like in shader graph, which you can, but if you want to use it in a more AAA context, point cache and skin mesh renders are the way to go, really.
Yeah, thank you for the question. Very good question.
Yeah.
Yeah, sometimes we have all these different tools, and you sometimes you can achieve the same thing with the different tools. And it might come down to which tool you're more experienced with. It might come down to which is the more optimized approach, and then in this case, what is the better option here?
Yeah.
As you're saying,
I just wanna add, like, I'm not a one size fits all kind of guy. I always tend to approach a problem with the best tool at my disposal, in relation to the project needs. Some projects, maybe because they're on mobile, you kind of need to just make it all in shader graph, right? But for the most part, you want to use the tool that's much more suitable for this kind of things. And it just so happens that Visual Effects Graph is so much more easier to work around with for these types of effects, because they're going to be grounded in 3D space. Like, so many good things out there are going to like vanish, and they're going to vanish outside the bounds of that mesh. And there's enough just things you can do in the vertex pass easily on a shader graph.
Perfect. No, just thanks guys. Was mostly asking because I am looking at prototyping some of these effects and was leaning towards shaders. You are more than welcome, and you don't stop yourself from using shaders in conjunction with the VFX graph. Go for it.
You use them in tandem. All these things, all modern AAA visual effects, they're always use of particle systems and and shaders. When you use them together, you get like really cool stuff happening. And the more stuff you can layer and work and you can time correctly in tandem with each other, the better it is. The more quickly, the better you're going to be able to sell that illusion in real time. So yeah, feel free, use both of them. By all means, I use both of them all the time.
Yeah. So let's light this car on fire.
All right. Let's back where I was, burning object, post-apocalyptic. So I made an actual. All right. So I'm gonna drag the graph that we used. I mean, at least a copy of it. You're gonna see that it's very weird because it's using my silhouette of the mesh, right? It's still using that point cache that we saw there.
Yeah.
But what we're gonna need to do is essentially, because we have the setup done right here, we're just gonna need to switch it with car on fire. And now we have a car that's on fire, except that it's not oriented in the right direction. It's probably just like facing downwards. You
can probably tell that's the silhouette of the car, but standing upright.
Yeah, exactly. And this is because we previously used a transformation matrix to shift and offset myself by 90 degrees because it wasn't aligned properly. But this mesh seems to be aligned well enough. So I guess we can maybe just remove it. And now you see it's, let me just pull it up so you can see it a bit more. Now it looks okay. It looks more flat. You can see it. There's more of a silhouette going on here. And now the only thing that's left to do is essentially just overlay it or parent it, right? And you get a burning car.
There you go. So you could imagine if this was just a square plane, it might look awkward at the corners or on the sides, but here it just lines up perfectly, and it realistically looks like this car is what's on fire.
Yeah, and ideally also in an actual game dev production environment, you might have like a basic shader template that people are going to derive their materials from. And sometimes you don't want to overload that basic shader template with additional effects, and toggles, because that's a lot of shader compilation. Sometimes you just want to keep things a bit separate. Up to you really, and whatever your needs are. We now got a burning car with just a few clicks and with some built-in tools inside Unity, thanks to the VFX Graph team.
Perfect. Incredible. All right, so what do we want to quickly set one more thing on fire? Chat, what do you want us to set on fire in this scene?
I'm gonna zoom in. All right, so everyone can see. We have like 2 buildings, some debris here. We got dumpsters. We got debris. We got sandbags.
The building, the dumpster. Okay, we need to set the dumpster on fire.
You guys want a dumpster fire?
Dumpster fire.
All right, let's do that.
You know what else was a dumpster fire?
What?
our rehearsals yesterday.
Oh my
But
god.
nobody needs to know about that.
No,
Today was
no.
smooth.
So many stuff going on behind the scenes. Guys, I think yeah, you know, people should realize how much work Hassan and Carol put into this stuff. It's crazy.
Oh, thank you, thank you. No, not looking for compliments.
I'm gonna throw it on
Just
your
making
way
jokes.
anyways. So yeah, we got a dumpster here.
Yeah.
We need its mesh. So yeah, we're gonna need the LOD level 0, the higher definition one.
Nice.
Yeah, so we're just gonna
More
click on
defined
this.
silhouette. Yeah.
More defined, yeah. Now we're just gonna put the dumpster here. I'm gonna bake it also 4K random distribution as well. Save the point cache. Go back into my stuff. Always keep your stuff organized, otherwise it's always a mess. And dumpster fire. Dumpster. Oh. There you go. I'm just gonna save it as a point cache. And I think we got it. So now we have a point cache. Time to create our
Thanks
fire.
for joining us, NPKNT.
Just gonna duplicate this and call it, and essentially drag it into our scene. Now you're gonna see, we still have the silhouette of the car, so we're just gonna shift that around and put the dumpster on fire. It's very easy. As soon as you got that system rolling on, really changing and adding objects is quite easy.
You just basically you make the fire graph once, and now you can just apply it to every object, and it just saves you so much time.
Yeah,
Every mesh you have in your game.
absolutely. And this is what it's all about. I mean, more time for iteration, more time for development.
Yeah.
This is really what you want in a game dev scenario. And look, it's really nice. And because we have soft particles not enabled, watch what happens. Like when we change our point of view, because of the soft particles clipping, you get like different, more like fade ins and fade outs, like that kind of make this stuff look more interesting.
Right.
Yeah, we got like a dumpster fire and a car fire right now. And maybe the dumpster fire is a bit too much on the spawn rate. Let's actually just spawn like 10 particles per second. So we get a bit more, not as intense, but still looking nice.
Amazing. You know what,
Yeah.
the scene, it's really looking like when you zoom out now, it's really added like movement to the scene. Looks a lot
Yeah.
better than it did when we first looked at it.
Yeah,
But I think the
absolutely.
only thing we're missing maybe from the scene is some raining cauldrons. Can we just
You want-
drop
you
that
wanna
in very
re-add?
quickly? Can we just
can
drop
chuck-
that in?
We can chuck that in. Yeah.
Yeah, I think that's what we're missing.
We're missing some
Raining men.
Is this where I put them? Oh, I guess they were just.
Oh, that's raining hamsters. No, don't burn the hamsters, coach.
There they are. This is what you asked for, Hassan.
Definitely the post-apocalypse. This is
Oh, great. See, this is the fun of playing around with it. I guess we forgot to switch it back to the raining Kojins, but really,
that's all good. That's all good. I think this is the perfect way to end the stream. I just want to thank everyone for joining us. Thank you, Kojin, for putting all of this together. That was really incredible. We learned about sine waves and modulation, noise and randomness. We learned about using texture as data, point caches, and we saw some really nice examples along the way. Thank you, Chad, for your incredible suggestions. We've given you the fundamental tools to build off of this. You can basically produce what we've done in any engine, right, Kojin? Like you could do this.
Yeah.
It's not limited to Unity, but VFX Graph is a wonderful tool that allows you to apply all of these principles that we learned today.
Yeah, a good way to think about it is that all these tools you see in all these different engines are still built around the same principles because we all have the same needs. So sine waves you're going to find in Unreal or maybe Godot. I don't know if Godot has a variation for that, but you can find point caches pretty much anywhere. Like you do them at Houdini as well. These are some concepts that kind of get you rolling, and same thing with noise and randomness and forces. I mean, that's universal when you're talking about tech art. This is our bread and butter, really, to make stuff happen. But yeah, don't feel limited. I just wanted to teach some of these principles in the 3-hour time we had. Sorry if we if we maybe wanted to have something more specific, but we try to make the most out of what we had.
Oh yeah, let us know in the chat what else you'd like to see from a Let's Dev stream. Jump into the repository. We're gonna put a link to the repository again to check out everything we made today. Please feel free to use Codrin's mesh. Do some fun things with us and tag Codrin on Twitter. We want to see what you do with that.
Yeah, please show me.
Yeah, please show us all of these like assets and all the VFX we made today will eventually go up on the asset store as a VFX Essentials pack. And please stay tuned for our next episodes in this series. Remember that the backdrop for all the effects we made today were from the asset store. We have the Discover 2021 asset store sale ongoing right now, 50% off. Some of the best assets of 2021, the post-apocalyptic asset, the animals that we were dropping from the sky, the meadows where the falling leaves were. These assets are all on sale. So check them out and stay tuned next week. Congratulations to everybody who won the Lego minifigures. Next week on Monday, we'll be giving out more Lego minifigures on our next stream, where we'll be playing Lego games from that are being archived in the Royal Danish Library. We're playing games from the Lego Ideas contest. So join Alice, Carol at Unity for that stream. That's gonna be really fun. That's Monday as well. So yeah, thank you so much. Thank you everyone for joining us. Thank you again, Codrin, and
thank you so much. And yeah, thanks for having me and giving me that space to spread that knowledge as well.
Absolutely, can't wait to do this again with you. Looking forward to it. All right,
appreciate it.
Thank you everyone. Thanks for joining us. Ciao.
Ciao.
Bye bye.